A very good morning to one and all present here. I, Kanisha, on behalf of the School of Architecture, Urban Development and Planning, Symbiosis Skills and Professional University, warmly welcome you all to the second technical session of the International Symposium on the future of skills in architecture, design and planning, a way forward for better industry and society. I'm elated to announce that the knowledge partners for this international symposium are Urban Village Charitable Trust and the Institute of Town Planners India. This symposium is curated with the aim to understand and deliberate upon the future of skills in architecture, design and planning, a way forward for better industry and society. Development and Planning, Symbiosis Skills and Professional University, warmly welcome you all to the second technical session of the International Symposium on the future of skills in architecture, design and planning, a way forward for better industry and society. I am elated to announce that the knowledge partner for this international symposium are Urban Village Charitable Trust and the Institute of Town Planners India. This symposium is curated with an aim to understand and deliberate upon the future of skills in architecture, design and planning, a way forward for better industry and society. Yesterday, through the deliberations, we learned various advanced practices, ranging from the use of VR in architecture to the importance of staying rooted in our principles, reaffirming that AI can never surpass architects. With blurring boundary lines today and intervention of technological advances, it is imperative to understand and gain knowledge, considering the global perspective in architectural practices. And therefore, we are extremely happy to have Dr. Jerry Anthony from the University of Iowa. Our expert speaker for today is Dr. Jerry Anthony, sir. Dr. Jerry Anthony, PhD, FAICP, is a global change maker. He holds a bachelor's degree in architecture, a master's degree in town planning, and a PhD in urban and regional planning. He is a tenured faculty member at the School of Planning and Public Affairs at the University of Iowa, a Carnegie One and AA institution in the United States. Dr. Anthony teaches courses in sustainable development, housing policy, land use planning, urban growth management, and international planning. Recognized as an excellent educator by the American Planning Association, he has received numerous teaching awards. Since the summer of 2015, he has also served as a visiting scholar at the Chinese University of Hong Kong. The students consistently rate his courses highly, regarding him as an outstanding teacher, and describe his classes as life-transforming. Dr. Anthony's research focuses on housing policy and land use planning in both US and international contexts. His current projects include studying and rebuilding of Cedar Rapids, Iowa after a devastating flood, and exploring methods to increase the adoption of cleaner alternatives to traditional wood-burning cook stoves, or chulas, in India. He was named the HUB Urban Scholar in 2002. His publications are widely published in the Journal of the American Planning Association in the past 25 years. His research has been funded by numerous institutions, including the Brookings Institution, the Lincoln Institute of Land Policy, and the US Department of Housing and Urban Development. In 2023, Dr. Anthony was a Fulbright Climate Studies Scholar in India, where he documented climate change mitigation efforts in several Indian cities, assessed their effectiveness, and explored their transferability to other urban contexts. Beyond academia, Dr. Anthony has played a pivotal role in advancing affordable housing and sustainable development. In 2004, he co-founded the Housing Trust Fund of Johnson County, which has since disbursed over $30 million to develop more than 1,200 affordable housing units. Welcome, sir. Over to you.
Hi. I can share my screen, right? Okay. Hmm. Just a second. can see my screen? You guys can see my screen, right? Okay, good, thanks. Okay, thank you very much for that really glowing introduction. I really appreciate it. Well, let me get into the talk right away. I'll cover three things, okay? Climate change, increasing urbanization, and sustainable development. There are many, many indicators of a warming world. The air temperature near the surface is increasing, humidity in the atmosphere is increasing, temperature over the oceans is increasing, sea surface temperature is increasing, sea level is rising, sea ice is melting, the glacial, the Arctic and the Antarctic snow caps are melting, glacial cover is melting, snow cover is decreasing, and temperature of the land is increasing. So there are lots of signs of global warming. And on the left is this famous hockey stick graph that shows how the temperature has increased over many, many years. And on the right side, you can see how carbon dioxide concentration in the atmosphere has increased very, very significantly. And especially in the last 40, 50 years, how they have changed so much. In both graphs, you can see the things from 1960. Now, 1960 was a turning point. After that, really, industrialization has taken over. Atmospheric pollution has really increased, and therefore greenhouse gas emissions have increased, and therefore global warming has really accelerated since the 1960s. These two images show the polar ice cap and the Arctic ice cap between September 1984 and September 2016. About 28 years difference, it is reduced by about 40%. Antarctic ice cap is not so much, the decrease is not so dramatic, but it is also decreased very significantly. The Arctic ice cap melt is so significant that for as long as we know, human history, it's not been possible to sail from Russia or China north of the Arctic Circle and come to Canada or the US. So north of the Arctic Circle was always frozen. The sea was always frozen. You couldn't sail from Russia or China to Canada or the US. But now you can, because the ice cap is melted, and there are many, many wide channels that ships can take to come directly from China or Russia to the US or Canada via the Arctic, so north of the Arctic Circle. So things are really accelerating very, very fast. Um, Global sea level is rising, and it is expected to rise between 1 feet and 6.5 feet in the next 75 years. But certainly an average of about 4 feet. And on the right, these are a couple of pictures of a large US town called Miami. It's in southern US. And this is expected to be, large parts of it are expected to be underwater, around 2 to 3 feet of water, by about 2050. There are other changes. Tree cover in mountains is changing, crop areas are changing, storm cycles, hurricanes, the intensity and frequency is increasing, and greater changes in seasonal weather and migratory patterns of birds and bees. Now, all of this is caused by greenhouse effect. A lot of this is a lot of the heat in the atmosphere happens for natural causes. When solar radiation comes in, some of the radiation is trapped within the atmosphere, and that causes heat. But then there are anthropogenic causes of heating, and these anthropogenic human cause. And that's because we emit lots of industrial gases, and these gases get trapped in the atmosphere. And once they get trapped in the atmosphere, they reduce the amount of heat that can go out. So this creates the greenhouse effect in warming place. There are many, many different kinds of gases that are out there. But I probably put up this one. So if generally is measured in terms of carbon dioxide, the greenhouse gas effect is measured in terms of carbon dioxide. And you can see these other gases, methane, nitrous oxide, hydrochlorofluorocarbons, HCFC22, which is what's in refrigerators, as a refrigerant, hexafluoroethane, sulfur hexafluoride, all these chemicals in multiples of carbon dioxide. This is what it is. So if 1 unit of carbon dioxide causes some harm, methane causes 84 times as much harm, and so on. And there are lots and lots of methane in the atmosphere. A lot of it is caused by from human actions. Uh, and anthropogenic greenhouse gas emissions have changed quite a bit. These are data from 1990 and 2017. You can see that in 1990, was probably a decade or so before you guys were born, one of the biggest causes was industrial processes, and then agriculture and power generation were the others. And 4 or 5 years ago, agriculture was, power generation was still big. Agriculture had caught up with it, but industry had reduced significantly. It had gone from 32% to 21%. Even though industries have expanded all over the world, they have become much more cleaner. Transportation remains a big chunk, and buildings, the heating, cooling of buildings, thermal comfort of buildings, and construction of buildings generates about 6%. So energy consumption is a big one. Transportation and buildings are another big one. Okay, so as architects and urban planners, we spend a lot of time designing, thinking about the buildings that you build and how to get from one building to another, about the cities that you build as urban planners. So about 20% or 25% of the 20 about 20% of all greenhouse gas emissions can be impacted by the work of architects and urban planners. Let's look at the top emitter regions. This is the legacy greenhouse gases emissions that have been emitted since say 1800. Okay? So 1800 to let's say 2000, over 200 years. The largest emitter has been Northern Europe, North America, and then Europe. And then China is only 5.5. India is probably around the same. But today, some of the biggest emitters are, China is a big emitter today. The United States is a big emitter today. The European Union is a big emitter today. India is a big emitter today as a country. On a per capita basis, India is still not a very big emitter, but on a per capita basis, there are other countries such as Kuwait, Qatar, Australia that are the biggest emitters. Okay, so now let me switch to the other topic that I wanted to speak about today, is increase in urbanization. Now, in India, you've seen how cities are exploding, and you've seen many cities grow very rapidly. This is not a common thing, but it's a very common thing in India, Nigeria, many developing countries. In comparison, the U.S. is the percentage of population in India today that is living in urban areas is about 34%. The percentage of population that was living in Indian urban areas in 1990 was 15%, 16%. So it's really increased a lot in the last 30 years. In comparison in the US, the total urban population today is about 80%. And the urban population in 1990, 30 years ago, was about 76%. So not much has changed in the US in the last 30 years. In 1900, 120 years ago, the percentage of urban population in the US was 65%. So in 120 years, the percentage of urban population has only gone from 65 to about 85. That is a movement of 20 percentage points. In India, things are moving very rapidly. Things are moving very rapidly in China. They have moved very rapidly in China. In China in 1990, the percentage of urban population was about 11%. In 2020, the percentage of urban population in China was 58%. China has a huge population, right? 1.3 billion. And so when so many people move from rural to urban areas, cities grow very rapidly. Similar things are happening in India today. And as you can see, the world for the first time became urban only in about 2012 or so, for the first time. Prior to 2012, the human race was primarily, the majority of people lived in rural areas. It's only in 2012 that it's become urban, and it is going to continue. This urban trend is going to continue. Most of the urbanization in the future in the world is going to happen in the global south, the so-called lesser developed countries. So it's India, Indonesia, Nigeria, African countries that are growing urbanization growth is rapidly happening very rapidly. This is where urbanization is going to happen. India itself, to come back to India's numbers, and so currently it's about 34% in 2024. It's about 34% urbanization. In 2030, it's expected to be 42%, and in 2050, it's expected to be about 53%. Okay, let's put some numbers. Okay, percentages don't clearly communicate the picture. So in the year 2000, which is approximately when most of the students here were born, let's say 30% of India's population was living in urban areas. India's population was about 1 billion in 2000. So 30% of that is 300 million. 300 million people were living in urban areas in India 24 years ago. Today it's 33.4. Okay, 33.4 of 1.2 million. Let's call it one third. So there are 400 million. One third of 1.2 is 400 million people. So in about 20 years, the urban population has increased from 300 million to 400 million. Okay? Now, by 2050, so this is in your lifetime, by the time you start working, you'll be working for 20, 30 years across your professional career. In 2050, the urban population is going to be about 55% in India, of a total population of about 1.7 billion. So 55% of 1.7 billion, let's call it a little more than half. So 850 million would be half, let's call it 900 million. So by 2050, in the next 30 years, the urban population of India is going to change from 400 million to 900 million. In other words, less than half the urban areas in India that would exist in 2050 have been built thus far. Okay, you live in very big cities, lots of development is happening, but lots more development is going to happen over the next 50 years. So the scale of urbanization that is going to happen in India is very, very rapid, and India has never seen that. Most countries in the world have never seen that. The only place that has seen that is China. Um, but there are differences in urbanization between China and India. Nonetheless, the amount of stuff that architects and urban planners have to deal with over the next 30 years is actually mind-boggling. Lots of cities are going to be built, lots of homes are going to be built, lots of buildings are going to be built. Okay, why is all this relevant to climate change? So this is where I'm trying to bring together everything and sustainable development as well. Okay? First, cities cover less than 2% of the Earth's surface. They consume over 75% of global energy, produce about two-thirds of all carbon dioxide and most of other gases. And by 2050, 75% of the global population, including population in Africa, which is only about 20% urban right now. The whole continent is less than 20% urban. All those countries will become all those countries, continents will become urban, and 75% of the global population will be living in urban areas. Now, urban areas are the drivers of the global economy. Okay? Most of the economic production in countries in the world happens in urban areas, and I'll show you some graphs in just a minute. Urban areas are already feeling the effects of climate change. Many urban areas are very, very hot because of the urban heat development. Many urban areas have very high concentration of pollutants. Urban areas also have large segments of vulnerable population. There are already, poorer people, people who don't have any options in life, they feel the impacts of climate change more than middle class upper income people. Okay? Middle class upper income people can mitigate some of these negative impacts because they have the wealth, they have the means, they have the resources to mitigate some of these impacts. But there are large segments who don't, and they feel huge impacts from climate change. But urban areas can also solve these problems because urban areas are centers of innovation. A lot of the discoveries in the world today, the discovery of the putting together the iPhone, putting together Zoom calls, Zoom technology, all of those things happen in urban areas. Because urban areas bring together a lot of people with different skill sets, with different knowledge, and put them in close proximity where they interact with each other. The urban areas have financial institutions that can invest in new kinds of technology, new kinds of innovation. So urban areas are the centers of innovation. Almost all the discoveries that we've had in the last 150 years have happened in urban areas. Okay? Because there is this cross-pollination of ideas, infrastructure to develop those financial, technical infrastructure to develop those innovations. Urbanization in the next 2 decades provides an excellent window of opportunity to make urban areas much better and reduce their climate change impacts. And urban areas are already at the forefront of climate change mitigation and adaptation efforts in many parts of the world. In New Zealand, which is a world leader in sustainable development, urban areas are really leading mitigating climate change. It's happening in some cities in Europe. It's happening in some cities in the US and happens in limited scale in some cities in other parts of the world, including in India. Because urban areas consume 70% of global energy, produce 60% of all carbon dioxide, and because 75% of the population is going to be living in urban areas by 2050, if urban areas are not sustainably built, they will actually exacerbate climate change significantly. Yet, as I said, there is an opportunity for us to make our urban areas much, much better going forward so that they do not impact climate change so much. And India is well positioned to do it because of this huge amount of urban population that is going to move into urban areas in the next 30 years, between 2020 and 2050. Okay? So, huge potential, huge opportunity, but also a big challenge. Okay, so let me just get a little bit into what is sustainable development. Sustainable development, the idea was the phrase was first popularized in the 1990s by the United Nations report called the Directive Commission Report. And this report said sustainable development is that development which makes efficient use of resources and uses them in such a way that it does not compromise the ability of future generations to access those resources. Okay, so in other words, just being very mindful of how resources are used and leaving these resources for future generations. Just like past generations, your parents, grandparents, great grandparents, and their generations left resources for us and you to use, we should be leaving resources for other generations to use. So, many of you have your phones open, right? I want you to Google something and I'll ask you what it was, okay? Google something called the Earth Overshoot Day and see how that day has changed from 1970 to 2024. And I'll come back to this later, okay? Once you have looked up, towards the end of my talk, I'll ask you what is the Earth Overshoot Day and how has that date changed from 1971, 72 or 70s, 1970s till 2024, over 50 years, okay? So those of you who have your phones open, look at your phones and get this info out. Okay, but over time we've come up with a more tangible definition of sustainable development, and that is this: is that development which advances economic growth, fosters equity among people, among generations, and yet does not harm the environment much. So in this Venn diagram, where these three circles intersect, that common area is where sustainable development happens. Okay, sustainable development, the history of sustainable development, the question of sustainable development is fairly recent. It's only about 70 years old in the global north. So that's US, UK, Europe. And it really took off because of some major incidents that happened in the 1960s. In the 1960s, it happened in Japan. Lots of kids, new babies were being born with lots of deformities, an arm missing, a leg missing, and organs, parts of the organs not very well developed. And people started looking at it, and they saw that in Japan, which was really becoming an electronics powerhouse after the Second World War in the 1950s and 60s, all the electronic waste was dumped into the ocean. And there was a reason for dumping it into the ocean. Back in the day, prior to the 1960s, whenever there was pollution, people felt that the solution to pollution is dilution. So you take any pollutant pollutants and put into a larger body of water, nature will take care of itself. So Japan was not dumping their waste into rivers and lakes and ponds within the country. They were dumping it into the ocean. So we're dumping all these electronic waste, and a lot of this electronic waste is highly mercury. People in Japan also eat a lot of fish. So they were dumping mercury. The mercury is contaminating the fish. People were eating the fish, and the mercury got back to pregnant women. And that's how these deformities came. This became a global thing. Globally, people became aware of this major thing globally, and they started saying, well, the environment, nature has only so much of recharge capacity or carrying capacity, a capacity to heal or absorb all these pollutants and take care of them. So we must do something. So that was in some ways, the beginning of the sustainability movement in action and policy in the global north. Then, as these things started happening, people said, "Hey, we cannot just talk about the environment and not talk about equity and talk about economic development as well, because economic development is important for people to feed themselves, and there are many people in the world today who don't have enough food," said world leaders in 1970 and 1980. So we must have economic development by also along with environment. So any kind of economic development requires some resources, extraction of some resources, harvesting of some resources from the environment. So it's a big challenge. And then equity cannot be ignored. Equity meaning different people groups in a society, in a country, in a region, and across generations, having access to opportunity, okay? Similar access to opportunity. And that's how all this happened. So first it started with the environment, then probably went to economic growth, and then to equity. Now, how do these things tie up? Let me take India's example. Okay? Say urbanization of the economy. This is the amount of urbanization, percentage of population living in urban areas in the different states in India. The darker the color, the greener the color, the more dark green it is, the higher the level of urbanization. So you can see in the southwest part of India, Gujarat, Maharashtra, central southern India, Karnataka, Tamil Nadu, Kerala, Goa, those are high urban percentages are higher there. So, for example, Goa is 76% urban. It's probably the highest urbanization in any Indian state. Followed by Kerala, then there is Sikkim at 61.1, Maharashtra, where you guys are at almost 50%, and Gujarat at almost 50%, Telangana at almost 50%. So the UP, Bihar, all those places, you can see the urbanization is very, very good. Okay, so urbanization, like I said, has potential for lots of problems, but urbanization is also good for economy, it drives a lot of the economy, you can see that here. You can see the per capita GDP, that is the amount of productivity per person in these different states in India. So you can see Sikkim, which had very high percentage urbanization, very high per capita income. Then Haryana, which has got 43%, very high per capita income. Tamil Nadu, Karnataka, all of them, very high capital income. So almost the dark green colors, the darker green, and here green is higher income. The darker green of the left map lines up with the greenish or higher income of the right map. So urbanization generally is a good thing. It's good for the economy, it can reduce people out of poverty, it can make the country much more prosperous. So urbanization is not a bad thing, it's a good thing. But it's got all these negative possibilities. I'll come to that in a second. So in India, right now, 63% of the total share of India's GDP is produced in the urban regions. Now you see lots of farms all over India, lots of people are still engaged in farming. 65% of Indian population lives in the rural area, but the 35% of the population that lives in the urban areas are what's driving the Indian economy. Okay, so 63% of the Indian economy is driven by the 35% who are living in urban areas. And the remaining 37% of the Indian economy is run by the 65% who are living in rural areas. And this is projected to grow in the next few years. Okay, it's going they say by 2020, 2020 is coming on, but it will be 75-80% in the next few years. So urban areas is where the economic growth is. Okay. But there are environmental consequences of India's urbanization that impact people in India first, but everyone in the world also, especially because of the scope and scale of India's urbanization. India is such a big, huge country, lots of population, lots of urbanization is happening. So the negative impacts of India's urbanization will be felt in India by people in India first, and but it will be felt by people everywhere in the world. And if everyone in the world, if the US, Europe, everyone becomes sustainable, and they design very good sustainable urban areas, that still will not save planet Earth. If India does not make its urban areas sustainable, okay? India and China are the two big ones. If these two do not make their urban areas sustainable, then regardless of what US does, UK does, Sweden does, regardless of what the rest of the world does, the human race is doomed. Okay? India's land cover is urban land cover is growing very, very fast. As India is urbanizing, a lot of the urbanization is happening at at lower densities than before. So if you look at the new areas that have been built around your city, whether it's Delhi or Calcutta or Mumbai or Ahmedabad, as you go further away from the city center, the new development that is happening is much lower density development than what's in the city center. Okay, so much more land is being consumed. And a lot of the land around cities is actually very good agricultural land around most cities. And that's not just in India, all over the world. So as low density urbanization advances, it takes away lots of very productive agricultural land away from the system. And you have lots of people driving great distances, lots of industries belching out lots of gases. So of the 20 most polluted cities in the world, number 1 through 14 are in India. So India has the gold, silver, bronze positions in in the most polluted cities in the world. Okay. And then there are some Chinese cities. The other six are Chinese cities. But number 1 through 14 are Indian cities. And you look at city number 20, it's PM 2.5, which is a measure of particulate matter 2.5 micrometers, is 86, around 86 PM 2.5 particles in the air per meter cube of air, and in Kanpur, number one city, it's double that. Okay, so these are all very, very high numbers. They are not just about the air that we breathe in and cause some lung discomfort. At PM 2.5, the particles are so small, they can get across into the brain and they start affecting our thinking, they start affecting our mental abilities and capabilities. So if you live in Kanpur and are a middle class person living in Kanpur and have lived there for some time, you are not functioning at your best mental capacity because of all the pollution that you experience, even if your lungs feel fine. Um, One aspect of cities that really makes a big difference, which architects and urban planners have big control over, is the backbone of the city or its transportation infrastructure, where the roads get built and how people commute from one place to the another, how much energy used in this consumption, how much time is used in this consumption in transportation, from traveling from one place to another. And as you can see in this graph, on the y-axis is the amount of energy per capita per year used by residents in these cities. And on the right is urban density. Okay? So on the x-axis is urban density. Higher the density, lesser the energy consumed. Okay, so Hong Kong, very, very high density among these cities here. And very little energy consumed per person. Why? When you live close to each other, and you live in high density situations, you can plan for other kinds of transportation other than cars. Okay, cars and people traveling by cars are the single biggest threats to Earth's existence right now. Okay, and India's urban population is increasing, India's car population is increasing, and the amount of driving that a person with a car in India is doing is increasing. Okay? It's a really big problem. And you can see that American cities are really, really bad right now. They use a lot of energy because people are living in very low density neighborhoods. And unfortunately, people all over the world, including in India, are trying to get to the American model of a city. Low density development, auto dependency, based on auto dependency. Urban planners in the US are losing their hair and losing their sleep about this kind of low density development. Okay? Urban planners are trying to make future development much more dense, future development less auto dependent, and future development more bus based or train based. Okay? Because then greenhouse gases would be lesser, lesser land would be consumed, lesser energy would be consumed, lesser emissions, and everyone would be happier and the earth would be happier. Okay, so what is India doing about this? India is urbanizing rapidly, and unfortunately, there's a strong emphasis on building more and more roads, especially from let's say 2019 onwards. India has been building about 10,000 kilometers of road per year. Okay. Now, part of this is needed because many rural areas in India don't have road access. So part of this is needed. But a lot of this 10,000 kilometers that they're making every day is in urban areas because urban areas are expanding at low densities and people are driving more. So it is to relieve congestion, accommodate urban people that this is happening. This is not the way that cities should develop in India. If India is going to reduce its climate change impacts for the sake of people in India, for their health, safety, and welfare, but also for the rest of the world. So there's a pretty significant need in India to change how the urban areas are developing. They are car dependent development pattern that is emerging as people become richer, as cities are becoming bigger. The car development pattern that is emerging, that's the wrong kind of development. It has to be either railways, it's possible. Many big cities do it. Hong Kong is 90% of the trips in Hong Kong are made by train. Trains are very efficient, very good, and they can be done very well. Okay, cities can make a big difference. I've gone on for a very long time. I'm going to switch a little bit and talk about buildings. The building industry accounts for 40% of total materials and energy use, 30% of raw material consumption, and accounts for 35% of world's carbon dioxide emissions in the manufacture of goods that are used in buildings and in the maintenance of buildings. Okay, uh, 1 ton of cement releases about a ton of carbon dioxide in the manufacturing of the cement. So there are certain design elements that can help make buildings, residences, cities, and commercial complexes less harmful for the environment. And you guys, as architects, are very familiar with this, but I'll just quickly run through them and then orientation, shape, materials. Orientation, you know how minimizing solar gain, summer maximizing solar gain, winter can be used. Design elements where you include less materials. So on the left is a wall with a cavity in between that includes the air resistance and the thermal resistance and insulation capabilities of the wall, and therefore keeping the building cool inside without artificial ventilation. On the right is a roof where this is a reinforcement concrete roof. So between the RCC, where the steel is, between the steel, remember, you don't really need concrete. So these guys have put roof tiles there. The white pieces are roof tiles. The brown shaded area is painted cement plastic. But the white areas are roof tiles that they put on the inside of the roof to give it a uniform appearance and also create an air cavity. Using different kinds of materials. Bamboo is very strong. There are many varieties of bamboo that can substitute for iron in foundations. And you could use renewable materials for roofing. These are some buildings in Kerala, India, by organizations there that have been doing this for like 40 years now, 40 to 50 years. And these buildings, when they were built in the 1970s, this particular building, when it was built in the 1970s, the engineers, local civil engineers, said this building won't stand for 4 years. It's stood for 50 years without, never had to be repainted, never had to be replastered. And functions very well. Another, this is a brick structure. This is a 2-story tall wall, 2-3-story tall wall, and it's a half brick wall. Okay? It's The entire wall is only 4.5 inches thick, and it's standing without any columns or beams to support it. And these are buildings in Japan. And we need to do this. You and I, as architects and urban planners, need to do it because climate change is something that is really uh, sea level rise is going to happen very quickly. I know all the urbanization that is done badly and all the efforts to reduce greenhouse gas emissions will not save them. So they want to move the entire population to Australia and to the western edge of Australia, where they will exist as a relocated independent country. Short. In Nepal, this is 15 years ago, the Prime Minister conducted a meeting in the middle Himalayas where in 1980s there was like 6 or 7 feet of snow, completely, permanent feet of snow that would be there. People never expected it to be that, but 6 or 7 feet of snow is gone, and now there's clear ground where they have a cabin. There's lots of flooding that's happening, and lots of protesting people have to do. People have, sorry, that's the normal level. People have to be relocated. So, well, this is my last slide. One is um, we need to change how we build our cities and villages. We cannot keep building with city concrete. We cannot build auto-dependent, auto-centric cities. Okay, and India has to take the lead. And you guys have to take the lead. You guys are just entering the profession, have to take the lead. Okay? Now you might think that, well, lots of the governments have to comply, rules have to change, all those things can change. Okay, how we build our cities is not like the law of gravity. It's not the law of nature, right? These are all man-made rules and regulations, and earlier generations decided to make those rules. You guys can change it. But it might take some time for you to change because institutions are embedded, these practices are embedded, but you can change. And many of you are, you're young, it takes some time to become powerful enough to affect these change, but you can change. But one thing, there's one thing, place, person that we have total control over. You might not be able to control the government of Maharashtra or the government of India. You might not be able to control how your parents live. You might not be able to control how your husband's, wife's, boyfriend's, girlfriend's live. But you have total control for how you live. Okay, so you need to make a change. You need to change your lifestyle. Don't take cars. Don't drive if possible. Take a bus, take a train, bike, walk if possible. And we need to change ourselves. And if we change ourselves, our voice is much more powerful when we tell others to change. And I'll quote a famous philosopher who you might be familiar with. Be the change you would like to see. Okay? So we got to change before we tell others to change. Well, I've gone on for so long, so let me end here. Thank you very much for listening. I'm happy to take some questions for a few minutes if you have any.
First of all, I would like to say thank you so much for joining in and talking about such insightful values about climate change and urbanization. This was truly an eye-opening session, and I believe seeing numbers really helped clarify the situation we are currently in, and really put everything in perspective in terms of climate change and the effect of urbanization along with sustainable housing. So, thank you so much for having us here. Thank you.
No questions? Okay, well, thank you very much for this opportunity. I'm going to sign off. It's almost 12:30. Okay.
change the conception of high density urban areas?
Okay. Electric cars. So let me answer that question first. Electric cars produce very little pollution when the car is being driven, right? But where is the power coming from? In India right now, most of the power, 60 to 70% of the electricity comes from coal. When you burn coal power, only 15% of the embodied energy in coal reaches the consumer. A lot of it is wasted in the production of energy, converting thermal energy to electrical energy. A lot of that is lost in the production, at the point of production, and a lot of energy is lost in transmission. So only about 15% of the energy contained within coal actually gets to a consumer. So, and the process of making of energy, electrical energy from coal, generates lots of carbon dioxide, lots of other sulfur dioxide, nitrogen dioxide, everything that is in coal. Coal has lots of impurities. All the impurities get converted to gases and released into the atmosphere. So if the electricity that you would use for your electric car comes from coal, you are actually doing more harm to the environment than if you were driving a petrol engine, a petrol car. So in China, where 70-75% of the energy comes from coal, in India, where 70-75% of the energy comes from coal, driving electric cars, you are harming the environment. You may think that you are not doing a good deed because there's nothing coming out of your pipe, from your exhaust pipe, but you're actually harming the environment much more than if you were using a petrol. How do you get people to change? And how to get densities, make higher densities? Um, the best way to do it is to do, when planning cities or planning extensions of cities, when governments are doing it, to engage in what is called transit-oriented development, where first the city government identifies where the city should grow, and they should identify places that are not environmentally sensitive. Identify, like, let's say, for example, if I'm just making this up, okay, I don't know Pune's geography, but let's say the northern part of Pune is environmentally less sensitive than the east, west, or southern parts. So the government of the Pune metropolitan area could say, well, when Pune grows, we want it to grow towards the north. So generally, they want to encourage development in the north. Then the government should identify certain spots and certain lengths, certain areas where they can extend light rail. Okay, identify places again within the northern area. Identify specific spots where there will be light rail. Identify certain places on this light rail route where they can have train stations. So build the train stations first, build the rail line first, and at each of these train stations allow for commercial and residential development to happen. Then, after these developments have been built out a little bit, let's say at each of these stations there are commercial complexes and there are, let's say, 50,000 people living in each of these stations. Start building one or two roads. Okay? So people will commute more by train, they will like the convenience of the train, and that's how you change behavior. And there are many such examples in the world of cities that have built themselves entirely density. Hong Kong. Hong Kong decided 50 years ago, 1970, that they will conserve. At that time, Hong Kong's population was 2 million. Population was increasing, and Hong Kong decided, about 20% of its total land mass was built up. Hong Kong decided in 1970 that no matter how much our population goes up, we will not urbanize more than 30% of our total land area. Okay? And to do that, they said they identified areas where there is no development ever. And today, Hong Kong's population is 7 million. So it's multiplied more than 3 times, okay? And the total amount of land that they've converted to urban uses, remember, it was 2 million, it was 20%. Now it's 7 million, 7.5 million or so. And it's 30%. So they're stuck by that, 30%. They've done it by high density, and they've done it by having a transit-oriented system where 90% of the trips are made by train, and everyone, CEOs of Fortune 500 companies, are very, very big, powerful companies, as well as the janitor who cleans the toilet in those companies, they both ride on the same train. And it's equally affordable for both. It's very cheap, very fast, very efficient, very clean. And it's very, very difficult to actually own a car and operate a car. So it's an Asian country, it's not a Western example. And so yeah, you can also do it. But there has to be a big change in the mindset of politicians, because road construction, is a money-making game for politicians. And so politicians are very committed to road construction. We got to get politicians in India away from road construction.
Thank you, sir.
We don't have any further questions at the moment, but thank you so much for joining in and hosting Q&A.
Thank you very much. Good night or good day to all of you. Bye.
Yes, thank you. Good night. I request the audience to remain seated and kindly maintain silence. Please put your phones in silent mode. Our dignitaries will be arriving shortly.
doubts and give me good advice about how to establish an institution. So thank you very much, sir. I'm very grateful that you accepted our invitation and are here. Uh, I also welcome Anand Khatri, sir, uh, who is the founder and director of UVCT, the knowledge partners for this symposium, who is always very, very supportive and is instrumental in that Erasmus project which we are doing with University of Navarra and Council of Architecture. I welcome Krishna Lila Murthy sir. I think he is coming to the university after 4 years, and sir, you will definitely see a lot of difference this time. We were very, very new when you were here last time, and I'm sure you'll be happy after seeing the work the students are doing, and we would be really glad to have your guidance. So, a very warm welcome to all of you, and I request our Honorable Pro Chancellor Dr. Swati Muzumdar Madam to felicitate all our guests. So, you can take over.
I now request our Honorable Pro Chancellor, Dr. Swati Mujumdar Ma'am, to kindly felicitate our first expert speaker, Dr. Ramnath Jha sir, on the token of gratitude. Thank you, ma'am. And I request our Honorable Pro Chancellor Ma'am to kindly felicitate our second expert speaker, Architect Krishna Murthy sir, Principal Architect at Ford Studio, Mumbai, with a token of gratitude. I request our Honorable Pro Chancellor, Dr. Swati Mujumdar Ma'am, to kindly felicitate our expert speaker, Dr. Architect Anand Khatri sir, Founding Director, UBCT, with a token of gratitude. Thank you so much, ma'am. I now request our Honorable Pro Chancellor, Dr. Swati Majumdar Ma'am, and all the dignitaries to kindly take the front row seat as we will be beginning shortly. Our next expert speaker is Dr. Ramnath Jha sir. Dr. Ramnath Jha sir belongs to the 1977 batch of the IAS. He has worked as a municipal administrator in Pandharpur and Solapur, collector in Ahmednagar, municipal commissioner in Pune, and metropolitan commissioner. He was a regional advisor in South Asia for the Urban Management Program of UN Habitat and Secretary of Transport, Ports and State Excise, Government of Maharashtra. After voluntary retirement from the government in 2008, he worked in the private sector as CEO and MD, Khed Economic Infrastructure Private Limited. In 2015, he led the Mumbai team for preparing the development plan Mumbai 2034 and was an advisor for the Mumbai Parking Authority. He is currently a distinguished fellow at the Observer Research Foundation, chairman of the Mumbai Heritage Conservation Committee, member of the advisory board of SSPU, member of the governing council Jalwani, and honorable fellow of the Indian School of Political Economy. Dr. Jha's works are towards people-friendly studies published by UNICEF and open essays published by Ishara. He has also co-edited Perspectives in Urban Development, published by Symbiosis, and has published more than 200 papers for the ORF on a variety of urban subjects. May now request her to deliver his address.
but I did not have the good fortune of looking at it in the condition, working condition that it is right now. And I was pleasantly surprised, happy I would say, not surprised when Dr. Swati is there, who is hardworking herself and a hard-working taskmaster, and she has put this place in great shape, and I'm sure all of you are fortunate in being a part of this institution. I'm not an architect is the first confession that I would like to make. So one of the questions that you could have is, what is it that I'm doing in the School of Architecture? Last week I was with the NESCO Architecture College in Mumbai, and I said the same thing. And I was making a presentation actually that was about urban development, but since the subject was acoustics at that time, I took the liberty of talking about something which did not really relate to architecture. I am going to talk today on skyscrapers. Skyscrapers, of course, is an issue of architecture, and a lot of architects in India have been clamoring that we do not have tall buildings as they are built in around the world. First in the West and then mainly in China, where they built a lot of skyscrapers. I am not going to go into the architectural aspects, I am not qualified to do that, but I would give you a sense of what happens when tall buildings are built. What are the pros of having skyscrapers in the city, what are the cons of that, and in the context of India, what is it that we need to do in relation to skyscrapers. As you know, if you look at the internet or YouTube, you would find a huge number of presentations that talk why is it that India is not building skyscrapers. So from that point of view, this becomes a subject of interest. Next, please. So, very commonly, skyscraper is considered to be a very unusually tall and multi-story building. Louis Sullivan, who is considered to be the father of skyscrapers, made that statement about skyscrapers that it shows power and altitude and must be a range of crowded soaring things rising in sheer exaltation from bottom to top without a single descending line. So obviously Louis was very fond of tall buildings and skyscrapers. He looked at them soaring in its height in the sky as something that was a great creation crafted by architects. However, till date, there is no clear definition of skyscraper, nor is there a universally accepted norm as to what is the height at which we will consider a tall building a skyscraper. In the 1880s, the home insurance building, which was 10 stories and 30 meters tall, that was for the first time considered a skyscraper, because tall buildings prior to that were there in ancient times, but they did not fit the definition of what we call a skyscraper today. Now, the center of tall buildings and urban habitat, they assign three characteristics to a skyscraper. One is height relative to context. What he means by that is that in a city, if suppose the normal height of structures is around 4 meters, and you build something which is 14 meters, then in the context of the surrounding, that becomes a skyscraper, because it stands much taller than anything else around. The other is proportion, meaning thereby that if it is a very slender building and it goes up, then to the perceiving eye of the human being, it looks as a very tall structure because of the proportion. So proportion was the other factor that defined a skyscraper. And then use of technologies, and we will talk about what technologies came which allowed skyscrapers to be built. Now, a skyscraper has to be self-supporting. The CTBUH believes that it should be at least 150 meters tall, or around 492 feet. And 50% of the total space that building has, that must be habitable. So if it has, say, 2 stories of car parking or other kinds of space, that is service space, that space is not counted as habitable because people can't live there. So total 50% of the space must be habitable to fit the definition of a skyscraper. As buildings became taller and taller, there were other words that were added to the definition. So you have super tall structures, super tall skyscrapers that are 300 meters tall, or mega tall skyscrapers that are 600 meters or more. They could be single use, they could be mixed use. So you could have a tower which is only residential, or you could have a tower which is residential, industrial, commercial, office space, and so on and so forth. So both types of usage is allowed in a skyscraper. Why did skyscrapers suddenly become the norm in many countries, especially the West? And the US was the lead country which started building skyscrapers. The background reasons for that was the economic might of the country. And when they had economic might plus the rise of urbanization, where more and more people were coming from rural areas and living in villages, then the need for office space, the need for residences grew. And as a result of which, there was a need to build tall buildings so that instead of using more space, you could marry the airspace into the building and thereby economize on spreading out horizontally and growing more vertically. So those were the main reasons with which skyscrapers began. But later, it became more of a display of the economic might and technical prowess, plus the ego battles of countries. So there was a lot of ego that went into the construction of skyscrapers. And if you trace the history, you will find that each country was trying to build taller buildings than what the others had built. For instance, when Burj Khalifa was built, which is currently the tallest structure in the world, about 29% of its structure is merely a pinnacle that they have put there, which is not usable. And it was added only so that it could be the tallest building on earth. So that kind of a battle started among countries in terms of ego. What enabled skyscrapers was the developments that took place in construction technology. Firstly, earlier periods had masonry architecture, which really did not, masonry techniques did not allow you to build very tall. These were then replaced by cast iron, wrought iron, and finally steel. And steel gave that element where you had both the advantages of being light and advantage of being strong. And therefore steel, the introduction of steel in buildings became a huge fillet and a catalyst in the growth of skyscrapers. And the other, of course, along with that was the safety elevator, because you could not expect people to climb 40 steps, 40 floors by foot and then come down and do this multiple times in a day. So when you had the safety elevator, which could take people at great pace up and great pace down, these three combined to give the skyscraper construction a big figure. Slowly, issues that emerged like overheating, strong winds, excessive light, they were resolved through new cooling techniques, use of glass, and innovative structural design. We'll talk about this when we talk about the Shanghai Tower, which was able to tackle the heavy wind loads that were coming into the building because of the height. So the structural design element was able to control that and control the high winds that emanated out of high stories and skyscrapers. As I said, US pioneered the construction of skyscrapers. This was more towards the beginning of the 20th century, but towards the end of that century, there were only 6 commercial towers over 300 meters that were built in US, and much of the construction were in very large cities like USA, Chicago, etc. Towards the 21st century, the shift of skyscraper construction happened from US to Asia, and it was led by China. By 2021, Asia housed 80% of world skyscrapers, and China built 1,575 skyscrapers since 2000. And then, looking at China, the UAE also joined it. Surprisingly, Europe did not enter this contest. And there are only about 5 or 6 European large cities that have some skyscrapers. And what was galling to the Europeans was that their cities were already built, they had beautiful heritage structures, and you know, in heritage the most important thing is the skyline that the heritage structures maintain. And if you have a very tall structure coming in between all those heritage structures, then the entire ethos of that area and the aesthetics, that gets disturbed. So Europeans were not very fond. There was also this cultural battle between the America and Europe. For all these reasons, there were very few structures in Europe that were built. There was a specific term that they coined at that time, and it was called Brusselsization, which meant that in Brussels, they took to constructing very tall buildings in the very heart of Brussels, which totally destroyed the aesthetics of that city. And they did not want Europe to go the same way, and therefore they said, we don't want Brusselsization in Europe. Now, at the beginning of the 21st century, China almost exhibited an obsession with skyscrapers, and that is obvious by the kind of numbers that we showed, 1,575 skyscrapers within 2 decades, 2 to 3 decades that they built. This was linked again to its target of 60% urbanization. China is one of the few countries which sets a target because it can do that and it can follow it up because of the kind of government that it has. So it had a 60% target of urbanization and shifting 100 million workers from villages into towns. As you know, China has a system where they follow what they call a hupu system, by which every person who moves from the village to the town has to have a registration. He cannot move of his own accord. He has to get permission from the government. So that system was loosened, and about 100 million workers, they set a target to shift them to the cities that they were building. And obviously, they found out that if they wanted to be a big economic power, they could not be that without urbanization, because urbanization and industrialization go hand in hand. So these were the targets that China set, and it backed that by investing 1 trillion yuan annually in redevelopment of rundown urban areas. Local governments, that is at the city level, they were given great incentives. Officers and the authorities who were there at the lowest level, they were said that if you are able to build so many structures at this speed, then these are the benefits and incentives that we will provide to you. So there was a real race among the local governments to build as many skyscrapers as they wanted. Uh, and they did this by subsidizing land prices. In certain cases, land subsidization went to the extent of 40% of the land value. And in China, most of the constructions that happened were in partnership with the private sector, but there was a strong element of public participation in that. So the public institutions also put in a lot of money. So it was actually state-driven more than private-driven. Cities competed with each other in building taller, and this spread to smaller cities. So earlier there were the metros, then cities of 3 lakhs, 2 lakhs also started building skyscrapers, even though it did not fit into the aesthetics of that city. Shanghai rose as a city of skyscrapers with the construction of Shanghai Tower, and around the Shanghai Tower in a very dense cluster there are a huge number of skyscrapers that were also built. So Shanghai actually became the #1 city of skyscrapers in the entire world. So Shanghai Tower was built between 2008 and 2015. It has 128 stories with 632 meters tall. Its elevators run at 21 meters per second. It has office, retail and leisure uses. It has observation deck, which is the highest at 562 meters. And you can see the structure, which is a little spiraling, and it was basically designed to offset the high wind loads that were coming. So the design of the architect actually was able to prevent that. And there were several eco-friendly features incorporated. When Shanghai Tower got built, it was considered the most marvelous piece of skyscraper construction that had happened in the world. I'm focusing on Shanghai Tower because Shanghai Tower played a dual role. At the beginning, it let the world know that this is the prowess of China in terms of construction. It has economic might, it has technical excellence, everything is there in China which the others boasted of. But then Shanghai Tower started having problems. Firstly, its occupancy was delayed because this was the first building in China which was built more than 600 meters tall, and the fire department did not know how to service this if, for instance, a fire broke out. Therefore, fire safety standards that had to be built there were not ready. So it almost took a year to get them ready, and finally then the building was certified. So the occupancy of the tower got delayed because of these bureaucratic hurdles for almost 1 year. In 2017, only 60% of space could be used. Rents became excessively high as large areas became unusable. We talked about the architectural design that was built to offset wind loads, but because of that, about 20 to 30% of space that could have otherwise been used, that could not be used because of the design. So the total volume of occupiable space became less, as a result of which the costs became higher for every square meter of space that was to be rented out. So rents became excessively high. Major water leakages between 9th and 68th floors destroyed furniture and electronics, and this took quite some time to settle because they first had to discover where the leak was coming from, and it took quite some time to rectify the whole thing. And then finally, the extraction of groundwater led to phenomenon of subsidence. Subsidence is a factor that if you are drawing water from underground, obviously the earth becomes unsettled because water was a large portion of that. And as you know, the earth then tries to find its own space. So it goes down and it tries to settle. So if your foundation is itself trying to settle itself through subsidence, the building is obviously going to get impacted, and that impact was later felt. So the incidence of subsidence that happened around that, and as I told you, the tower is surrounded by a lot of tall structures. So the weight of these structures and the water that had been drawn out of the earth to build these led to this factor of subsidence, which was a major fault that was realized by the Chinese. So there were more problems then that came into skyscrapers, and these were not all related to architecture or mistakes made by designers, etc., but they were beyond it. In 2012, the Shenzhen Electronics Group Plaza, which was again a very tall structure, a skyscraper, had to be evacuated as the structure began to shake. In fact, on YouTube, you can see pictures of how the tower started shaking and the panic that engulfed the entire area, because those who were living both inside and outside, they were really overawed by the kind of thing that was happening. Further, government was irked by copycat buildings. In this race for building skyscrapers, there were cities, for instance, that put up a replica of Eiffel Tower. Another one put up a replica of Empire State Building. And the Chinese top government got extremely irked by it because they were trying to show their own culture and their own strength and not trying to copy what others had already done earlier. So, government worked by copycat buildings without any care of the local context and culture. They were angered by vanity projects that were done without a study of requirements. So, just as we were talking about the ego clash between countries, there was ego clash between cities. So if one city built 300 meters, another neighboring city would like to build 350 meters. So this kind of race was called vanity projects. So this was not liked by the central government. Some of the skyscrapers could not be completed as cities ran out of money. So you build about 40 floors of a building and 20 floors are still to be built, but there is no money to go ahead and build them. So it was left in limbo. China got at the same time engulfed by a real estate crisis. And many of its giant real estate companies that were involved in construction, like Evergrande, they collapsed. And once they collapsed, obviously the projects that they were undertaking, they had to be either completed by government pumping in more money, or they had to be left just as they were. In many cases, where very little construction had happened, orders were issued that these buildings must be demolished. So structures that were being built as skyscrapers had to be demolished, and many examples of that exist in China. Government tried to bring regulatory incentives. People were not ready to invest in property. Since one of the problems was that when these structures got built, the area that had been built had to be let out or sold to people. But because of the kind of thing that was happening in the real estate sector, people lost faith in investing in property, and therefore they were not doing that. Then government gave incentives, very low rate loan, advances of a very high order, yet people were not prepared to pick these up because they did not have the confidence that the real estate sector would be able to stand on its own feet later. So when all these problems were faced by the Chinese came up with a notice on further enhancing the management over urban and architectural styles in April 2020 and follow-up order in October these two orders were issued. Now, what was the reason? The reason was that in the assessment that they had made, re-evaluation of the entire thing that was happening in the area of skyscrapers. When that reassessment was made, China felt that we cannot go the same path further and we must make certain drastic changes. What was those changes? Brought to a halt the blind race for tall. New buildings over 500 meters were disallowed. Buildings above 100 meters were to be in sync with size and space of the city built in. Building plagiarism, imitation and copycat behavior forbidden. Buildings taller than 150 meters were disallowed in cities with less than 3 million people. Now these were the beginning orders, and we have reason to believe, although these orders have not come out in the open, that China has over a period of time become more tough with skyscrapers because of the crisis in the real estate sector and because of building when buildings were not required. That has finally led to the Chinese halt on building skyscrapers. As we know that the population of many countries is also going down, China is facing the same problem. So I'm sure that factor also has weighed in at a certain point in time when they feel the kind of housing that we are building, they have come to a situation where a lot of housing is lying vacant and they have a feature of ghost towns in many areas where huge chunks of properties are unoccupied, though built several years ago. Now, what are the arguments? Taking lessons from this, I am trying to summarize what can be the arguments for and against skyscrapers. So, it uses limited area but provides greater living, working, business and recreational space. That is obvious because your ground area is small, you marry air space into the building and therefore you can provide for many more in a very tiny piece of land. It addresses housing shortages. It supports economic productivity and agglomeration economy. Now, economists are quite happy about this because this is what they have been harping for. The agglomeration economy is a factor that what they say is that if there are lots of people who live together, there are lots of activities that happen and therefore the productivity of the city goes up. And skyscrapers are an excellent method of building agglomeration economies because of marrying so many people and so many activities in such small areas. It saves agricultural land. It's obvious that if you build tall, then you don't spread horizontally. It supports transit-oriented development because the example of Hong Kong is there where 90%, almost 90% of the people use the metro system because the housing is constructed in such a way that people live next to the public transit and therefore they just have to come down, take the public transit and travel to their offices. So that TOD concept gets very well served. Mass transit gets supported by box office money. The collection box office collection is high, and it limits personal transport because if you are living so close, you don't need to have a subsidiary mechanism by which you reach the station. Station is right next to your house. It's a great tourist attraction, and the example basically that is given of skyscrapers is the Burj Khalifa, which has in fact attracted more tourists than say the New York New Empire State Building or the Palace of the Queen in England. It reduces carbon footprint and allows more space, open spaces. These are some of the arguments that we give in favor of skyscrapers. Against, taller the building, more expensive the construction. Skyscrapers decidedly cost about 2.5 to 3 times more than the normal building because of the kind of construction they need to do because of the height and the strength and the other features that will go along with the tall building. it does not add to affordable housing. Obviously, if it is costly, then people who are poor are not going to live in these skyscrapers. It's meant for the affluent, and therefore, especially in Indian conditions where metros and the large cities have a problem of more of affordable housing than anything else, the skyscrapers don't add to affordable housing. It inflates land prices, makes affordable housing difficult. Very few of them are tourist attractions. This is to counter the other argument that they are tourist attractions. So you have 5,000 skyscrapers around the world. Everyone does not build all the tourists don't visit all the 5,000 skyscrapers. It's only one or two that get that kind of footfall. It negatively impacts heritage precincts. That's obvious given the example of Europe. It's not environment friendly, guzzles electricity to heat or cool, high cost of maintenance. And if you take all the activities that have happened right from the beginning to the end, then this argument that it has low carbon footprint that does not stand to test. And we have seen that from the days of the 9/11, that tall buildings have been the targets of acts of terrorism and war, because it's much easier to hit them and pull them down, and it costs it causes enormous destruction. Now, what are the lessons for India? Well, my personal feeling is that you build a structure only if you need it. So if there is, say, a city where housing is required, and let's say apart from affordable housing, other kinds of housing or office space are also required, or institutional space is required, then if you have a good reason for constructing it, then you construct it. India's urban problem is affordable housing. Obviously, that does not get helped by skyscrapers. Indian cities are some of the densest in the world, so we are not in a position in which, say, the Chinese are, or the Western countries are, that are losing population now. We are already the densest cities. Mumbai is around 30,000 persons per square kilometer, one of the densest in the country, in the world, and other cities are not very far behind. Most of them are very dense. Asian cities are in general dense. So, do we want to further densify these cities is an argument where there could be pros and cons, and that needs to be debated. Climate change and city sustainability call for lower densities, because if you have a very dense place and if you don't have open spaces, and if there is, for instance, a climate disaster, there is no place where you can shift people, and therefore one must take stock of what would be the impact of climate change and city sustainability in these kinds of buildings. And in any case, it should not be a show-off kind of a tool, because money has to be used wisely. Kings who are there in the Middle East, they don't need to worry about this, but democracies need to use their money very carefully and for good purposes. So it definitely cannot be a show-off tool. Thank you, that was the end of it. So what I basically presented before you is how the skyscraper boom went up, what happened that it has gone down, why is India overly worried that it does not have skyscrapers. Just because someone has something, you don't need to have that as well, unless there is a justification for that. That in brief is what I wanted to present before you. Thank you. If there are questions later, I would love to answer. If there are any questions, you can shoot them right away.
you.
It was quite a comprehensive,
So, is it necessary to build skyscrapers? Because we can live in normal buildings. It is not necessary to live in the sky. We can live on the land. And it is very harmful to build skyscrapers. They can fall also. So, because of the competition, is it because of competition?
I didn't get your question. Can you repeat it again?
Is it necessary to build skyscrapers?
No, that's what I argued. My basic argument was build them only if you require them. So there must be you don't need to do an audit of the building after it is built. You also need to do an audit of the situation in which you are going to build. If it is not required, I don't think there is any necessity of spending so much money on a skyscraper. I agree with you.
Sir, what do you think? Is it good to spend a lot of money and build a tall building, and after a few years we get to know that it is going to fall and it has so many damages?
No, it may not fall. It may not fall. If you build it rightly, it won't fall because they are strong structures there. And the norms of building tall there, I was chairman of the high-rise building in Mumbai. Of course, in India, we don't have a clear definition of high-rise. The building code, the National Building Code, talks of high-rise of any building which is above 15 meters. In Mumbai, the high-rise committee considered anything that was above 100 meters as high-rise. So we used to look at those buildings. So you look at a lot of factors when you go tall. One was the quality of earth on which you're building, the kind of airplay that you will have to deal with. So all those features are taken care of. So construction is not of a quality that will allow the building to fall, especially because it's tall and it involves so many people. But the question is, what is it that you need in the city? Is it affordable housing? Is it office space? So make a proper study. I think for each of these large projects, the amount of time you take on the table to study that needs to be sufficiently large, so that you have considered everyone's opinion, you have taken into stock all pros and cons of the project. But if the answer still is yes, we should go for building, go ahead. She has a question. Go ahead. What she's saying is India's organization better served by decentralized organization and skill planning rather than centralized. I would only be repeating what Charles Correa said in his national report on National Commission Organization document that was prepared in the 1980s, where he identified at that time 350 small and medium towns and said that these have growth potential and these are the places where we should invest. But I don't think the country has followed that advice that Charles Correa gave 30 years ago, 40 years ago. So for a country which is as large as ours, it is obvious that the kind of organization that will happen cannot be fitted into 10 mega cities that we have currently. And one of the reasons why all these cities are going down is because they are overloading themselves beyond their capacity and they are not able to manage them. This has happened to Bengaluru, this has happened to Pune, this has happened to Mumbai. So decentralized organization is the key to way of going ahead as far as India's organization is concerned. You would say that destroys a lot of agricultural space. For your information, the total space that is occupied by cities in the country is 3.5% of the entire livable area in the country. So there is concentration of population in cities, so we don't use too much of space. So if we use another 350 cities, there it is not going to go beyond 5% in any case. So I think that argument that you're going to destroy agriculture does not stand. And it is answered by the fact that most cities are now picking up on urban agriculture. Because in cities you can do agriculture. You can use a lot of space. Singapore is one of the examples of greening and agriculture creation in buildings. So I think what you're saying is absolutely right. Thank you. There was some question that side. Yes, ma'am.
So, how can we approach the development of skyscrapers without causing any harm to the skyline from the existing heritage structures?
Well, if there is a real skyline in some area, let me give for instance the example of Mumbai. Uh, if you are going to build, say, on a marine drive, marine drive's aesthetics is because all buildings look similar, right? And that gives the beauty to that. So there are strict regulations about marine drive that on the front row, nothing can be more than 28 meters. You go behind, then you can use the line of vision to go slightly higher, but not beyond a certain height, which will rob the aesthetics of the marine drive. So you're right. I mean, you can't build skyscrapers where you want. I don't think we have that nuanced view in this country as well.
Yeah, and heritage is again, it's about the identity of the city. You know, you disturb that identity, you disturb that heritage. So, in every heritage precinct, there are certain rules and regulations which you have to follow. So, and that is to maintain the skyline.
Europe did not buy
Yes,
into
yes.
construction of this structure, for mainly because why do people go to Europe? They go to Europe to see this beauty of the heritage structures and the entire precinct in which they are situated. Now imagine if you build skyscrapers in that, the whole thing goes away. You're right.
Good afternoon, sir. So, according to you, what are the best construction techniques to build the skyscrapers? Best construction techniques to use skyscrapers?
That I'll ask you, you are the architect. I'm not going to talk about construction techniques. Although we know the best construction techniques have to be used. I forgot to tell you that one of the arguments now being given by alternate kind of skyscrapers is wooden skyscrapers. So wooden skyscrapers are also being tried, especially by the Japanese, where they use a lot of wood, and there are gluing technologies by which you can go to great heights. They are very light kinds of structures. The problem with there are two problems that are pointed out. One is fire, and the other is destruction of forests. So the environmentalists obviously are not going to like wooden structures. Thanks.
So do you think it's ideal to construct a skyscraper in everlasting city in India so that it becomes skyscraper as well? Like for example, like we take an example, Pune as an example, it boosts the tourism as well in the city. So do you think it's ideal to construct a skyscraper in India to boost the tourism of the city as well?
Boost tourism.
Yeah, like actually skyscraper as well as it boosts tourism in Pune itself, like we take as an example.
Well, if you want to boost tourism, India has already potential of great tourism. I think first we should take care of tourism where it can happen. It's not happening. There are very few countries that already have tourism sites as rich as India. But because the policies and the total mechanism has not really worked, we have not had that kind of tourism. But I think it's a far-fetched case of trying to build a skyscraper to attract tourism, especially when you're not sure. So you could have built it, spent a lot of money, so you've invested something in which the risks are very high. But my personal view is that, especially for office spaces, etc., commercial spaces, skyscrapers can be extremely beneficial for the simple reason that urban agglomeration economy that really starts working there very well. As far as residential spaces are concerned, if the private sector has enough clientele that wants that kind of structure where you go on top floors, where you have good play of air and no noise, if that is there, go ahead. My basic fear is that the public sector should not enter into these kinds of construction because public money needs to be used better. But if there is a private sector developer who wants to invest in that, I don't think there should be any reason why they should resist from that and prevent it.
If there is a dilemma between whether you should save a heritage on that particular city which is like existing in that city, or you will idealize a change in that city which is current, like in that particular situation. The city needs to be need that change economically as well as environmentally. And will you save the current situation which is going on heritage, will you save the heritage or go with the change in that particular city through a skyscraper or any structure which is better in future terms or in the current terms or in the current situation which is economical as well?
Understood. Understood. So essentially you are saying if there is a heritage structure and there is a need also for a tall building to come there to serve the economic interests of that city, which are you going to choose? Now, it's a very good question. First, I must admit that this is a policy issue that comes up several times. I think the answer that we give to that is what is the importance of the heritage structure that stands there. So let's give the example of Mumbai again, because all of you would be aware of Mumbai, or say Delhi. So if you have to demolish the India Gate and build a tall structure there, so the heritage importance of say the CST, Chhatrapati Shivaji Terminus, or India Gate is far high. And therefore the decision that then would have to be taken is that if you have to build this structure, build it somewhere else. But if you have a heritage structure which is low graded, that has a number of replicas all around, and you have to come up with something which is extremely important for the city, economically or transport-wise, etc., then you would have to take a decision to do away with that heritage. And it has happened. Small areas, for instance, I remember during my days in the heritage committee, we had to give permissions to the construction, say, of metro or to the construction of coastal road, because they were very important projects and there were small kinds of heritage structures that stood in their way. So we had to weigh in favor of these projects that were extremely important. So I think it's a very nuanced kind of decision that you have to do, where you will have to weigh the importance of the heritage structure and the importance and the significance of the projects that were going to take place. Yes, sir.
So my question is that after the September attacks, what are
I don't think there was any rule that was passed in the United States after 9/11 in regard to skyscrapers. As I said, the construction of skyscrapers on its own has petered out in the second half of the 20th century in the United States. But if the private sector wants to construct a high-rise building as high as the Empire, the Twin Towers that were attacked, I don't think there is anything that prevents them in the United States today. You could still go ahead and build there. But the United States itself is not going to invest in they are not invested in the construction of skyscrapers. It's all privately developed.
Good morning, sir. Do you think it was a wise decision to reconstruct the Twin Towers after the attack, especially when the Symposium was being bombed?
That must be a decision that the US government would have taken. As I told you, the
Red Cross was announced, there was no defense mechanism that time. Even after reconstruction, also there's still no defense. So,
it must have been a decision taken by the owners of the Empire State Building as to what to do. Do we construct it again or do we leave it the way? So they did something about it. But as I said, as a policy issue, there is nothing that prevents a skyscraper to be built. I think I'm eating into the time of other speakers, so probably we'll have to close the questions. Yes, ma'am.
Do you think the entire self-sufficiency can be built in one vertical skyscraper?
Pardon?
Do you think that an entire self-sufficient city can be built vertically like a skyscraper?
That's a good question. Why don't you try it out? Since you're an architect, I personally believe that a village like small town can be built in a single structure because it's possible to allocate various spaces within that building for various purposes. So what does a city require? Most of the requirements could get satisfied. So you could have recreational spaces, you could have office spaces, probably industrial spaces that are not that cannot go with that structure. They would have to be located somewhere else. But otherwise, most of the functions, schools, hospitals, etc., could be a self-sufficient town. I've thought about it, but I have not worked out the details, and I believe that it can be done. A village, for instance, is about 2,000 to 2,500. You can, in a skyscraper, have a 5,000 town living in a single building. Possible. It's a good idea. Hope someday you'll be able to build that kind of a city.
I will work on this.
You close it?
So considering the spatial and economic efficiency of skyscrapers, then why would a private development say no to skyscrapers in city? How will I convince them?
Convince whom?
The private development that don't go for skyscrapers.
Why do you need to convince them?
Because like
If they want to build it,
yeah,
and if they think that they have enough value they can get out of that, then I think
is there like some alternative like
this? No, obviously the developer who is going to develop that is going to weigh the pros and cons, and he will be able to do it better. Suppose he has been able to, he wants to build 200 flats in a big building, and he has been able to garner support from 200 expatriates who are prepared to pay him through the nose. So if he is going to make a neat profit and he wants to do that, why should an architect tell him, please don't build? So either you have to be an architect or you could be a social worker. You should have a social angle in your architecture. I'm not saying you should not consider that. But these are questions beyond that. This is a question of profit and loss. So if the builder wants to go in and he's certain that he will make a neat profit, I think you should be supporting him. What you should do is, while you're trying to do the project, you will try and see what are the ways I can keep the cost down, what are the ways by which I can improve its efficiency, how can I make it more aesthetic. So those are things that you will watch out for.
Thank you.
Thank you.
Thank you, Dr. Ramana Jha, for sharing with us such an enlightening presentation. Skyscrapers are assumed as the way for the future, and it was truly insightful to hear all of the fors and against, as well as the case regarding China and its Shanghai Tower. We truly appreciate your time and expertise. I would now like to introduce our next expert speaker, architect Krishnamurthy sir. Forge Design Studio, initiated by architect Krishnamurthy, is an architectural design house committed to crafting a future where technology and design seamlessly intertwine. Together with architect Anushka Maitri, the studio has redefined the discourse of contemporary architecture, pushing the boundaries of digital design and fabrication. From humble beginnings, the studio has grown exponentially, establishing itself as a powerhouse of design and fabrication excellence, housing a team of architects, designs, and skilled artisans. Located in the vibrant city of Navi Mumbai, with an in-house work lab powered by the latest advancements in digital technology, the studio is dedicated to building iconic designs that epitomize excellence, sustainability, and the perfect union of AI, 3D modeling, and research. The studio's journey has been shaped by years of experience, research, and a profound commitment to bridging the gap between design technology and the built environment. Their mission is to inspire, create, and transform spaces through revolutionary architectural designs, bespoke furniture pieces, and artistic marvels. Forge Design Studio is a gateway to a future where architectural innovation and technology harmoniously coexist, redefining the landscape of design and manufacturing. I now request Sir to deliver his address.
Very good morning to all. A lot of questions were put across. Amazing to see that these many questions have been put across to a speaker. And Sir has literally, with patience, he has delivered whatever he has to say. But there's one question that I would like to ask to all of us, to myself also. The idea is today, as architects, I think there are almost 450 colleges all over India. Each college has got a minimum of 40 students capacity. So 40 into 450, that is almost, I think, 16,000 people, 16,000 architects passing out from all the colleges of India today every year. And this has been happening since the last 20 years, I suppose. So all intelligent people coming out into the societies, into our cities, into the villages, yet we are sitting here today talking about problems. Do you think that we are doing our job rightly or correctly? Do you think so? Yes or no? So what do we need to do then? Huh? What do we need to do then? Have you ever thought about it? We are in the 21st century today, thinking about technology, thinking about skyscrapers, and still there are problems. Somebody asked the question, can we house everyone into one building and build one city? Yes, people are making it. We know that there is a building called 9.
that people are building in UAE, right? Then we are also talking about somebody hitting a skyscraper and collapsing it, right? Then if you are going to house everybody in one building and somebody attacks, there will be no one left in that village, right? Just imagine. So there are questions, there are debates, there are answers. Are these questions really viable? If so, then what are we still doing and why are we talking about so many problems? Every time, every lecture that happens, there are a lot of problems that we talk about. But are we doing our duties? First thing is, are we really doing our duties? First. Second, are we following the rules? Very important. We know how to break the rules and still sustain and talk about sustainability. So there are many problems. But as architects, the Brahmas, as architects, we are the creators. We are the one who is actually trying to tell people how to live. If we do mistakes, then these are the problems that are going to arise. And all the problems that we are trying to talk about today, I mean, the way we are living today, and all the problems that are getting arise, is only because of the kind of mistakes that we have made. We as citizens of India, as architects, as designers, we really need to plan well. We need to think well. It's not money all the time that we need to earn about or think about to sustain ourselves, but it is about how to move forward in life and also deliver right things in the right place. Heritage is necessary, but future is also necessary. Heritage is a design which is there. It is a history. But there are a lot of mistakes even in heritage. We today have to redefine the heritage and design buildings so that they become heritage in future. Right? So there are multiple things, multiple layers that we need to think about and design, plan properly, move ahead in life in such a way that we don't have these kind of problems that will arise in the near future. I hope, we look forward to that thing. Coming to my session today, we are also trying to practice ourselves in such a way that we can redefine ourselves as architects, as designers, and make sure that in a design, there is something called research, which is necessary. So as a firm at Forge Design Studio, we do a lot of research, both on materials, in technology, and in the designs that we build. So our designs start from a micro level, such as furniture pieces, and go up to large buildings. So it has got a wide range of design dialogue that happens at Forge. So for me, what I am trying to start is this working? Okay. So what I'll try and tell you is how we practice as architects. So I have a studio in Navi Mumbai. The studio is not just about architects sitting in an office with computers and practicing, but studio also works with machines. So architecture is not just about designing on computers. That's what we felt. Architecture is also about planning, designing, and also executing what you design. Okay, that's very important. So when I say executing design, that means I as an architect should know what I am executing, right? The biggest flaw in the architecture industry today is we design, others build our designs. Others means the contractors, and the contractors give our designs to the subcontractors, and then the subcontractors give it to the laborers, where there are again different layers, one skilled and unskilled. So what is happening is the data that you are trying to accumulate together as a design analysis is being transformed from one person to the other. At the end of the day, who is building it? The skilled and the unskilled labor. And the end output, we all know, because of which we are talking about problems today. So for us, as Folds, we thought we will clear this gap. We'll make sure that there is no gap between sending the information from one person to the other. We will become the contractors, we will become the designers, we will become the people who will build our designs. So hence, if I am trying to do this, that means I don't have to think about large volume of projects. I can still survive by doing minimum projects, but detailing it out in a very usable way. That is very important. So for me at Forge, what we have done is our practice has changed from a regular architectural practice to a practice where we design and build things. But how do we build it? We're going to build it again with the same people that we're talking about. The only thing is, I as a person will be more involved with these people. But will that problem be solved? No. Then what do I need to do? I need to get tools. Tools are something which is necessary. And today we are in the 21st century, right? In the 21st century, we know that there is technology that is available to us. But unfortunately, technology was never available to architects. It was always available to mechanical industry, automobile industry, defense, medical, and other areas. But for architectural industry, tools were never available. So we thought, why not get these tools into our own premise, understand these tools better, and execute our stuff. So hence, what are these different kind of tools that an architect needs today is what I'm going to try and tell you in the first part of my session. So this, starting with this, is a water jet machine. Do you guys know what a water jet machine is? Anybody? Okay. So I'll not ask this question again. Probably we'll be losing our time. So there are a lot of machines that are available today in our architectural practice. This is called a water jet machine, which you as an architect should know about, and how this machine will help you build your designs. Okay. Water jet machine is a machine where you cut different kind of materials. What are the materials that you can cut as? Metal, wood, stone, ply, glass, right? These are the regular materials that we tend to use in our practice regularly. And with these materials, we try and build our spaces. So this machine, this tool, actually redefines the way it can help you out in terms of cutting your details, getting your details perfect. So if you want to do an inlay, if you want to insert two different marbles and make a flooring pattern, it can cut. If you want to insert metal and marble together, it can cut. If you want to insert wood, marble and metal together, it can cut and give you your designs. But the only thing is, this machine is a two-dimensional machine. A water jet machine is a two-dimensional machine. Anything that is flat in design but multiple materials together, you can use this as a machine for your design. Okay, so this actually uses water to cut your materials. One. Plus there is something called a silt, that is soil, that's garnet. It is 0.2 mm micro mm. Your sand particles along with water, they pass through a nozzle at a 50 HP pump with that pressure. When I am saying a 50 HP pump with that pressure, that means it can cut up to 200 mm metal. Just imagine 200 mm thick metal, this water jet machine can cut. And it can cut up to 500 mm thick stone slab. So that's the power of this machine. So imagine that you as architects, if these kind of tools are with you, what wonders you can create. Right? So these are the tools that we need to understand. What have we done is, you can see they're cutting glass that we're using this machine. That's a mirror. So you can cut mirror to different forms, different shapes, different sizes, and get your design built. Okay. What are the other things that we have done? We have designed a swimming pool. We have designed the swimming pool, which is 20,000 square feet of a pool, but using this machine as the basic thing, we have crafted the flooring pattern around the pool. It has got its own concept, it has got its own design factor. But for you to understand that how this tool will help you build your designs. So this is what we have done by using this tool. We have cut different pieces of tiles, marbles, granites, composed them together to create that kind of a design pattern. Then what else have we done? We have cut wood. That's a detail that we have done. It's a lounge, it's a sitting space inside a T1 departure lounge in Bangalore. So that's a lounge that was created by cutting wood, which is birch ply, stacked together. And you can also see that they are not stacked in a linear way, they are also changing its form, it's changing the direction. When it's changing the direction, it has to be placed at a right place. So that means there is a spacer which is needed between two ply. You can see those spacers also. See? You can see those spacers also. Every spacer has it's got its own dimension. That means this dimension, where do you evaluate this dimension from? From your drawings. And from the drawings, it has to be too specific. How will you make it too specific as a spacer? Your machine will cut properly and give it to you. Then it can be placed perfectly so that you can make your design in a proper way. So that's how these machines help you out in getting your designs done. In that case, what you see, a marble has been precisely cut, laid one over there in such a way that the grains follow. That's not a solid marble. It's a stone piece of a slab which was cut into multiple pieces. It was joined together so that it looks like one piece. You can see here there is a metal structure, then the whole marble was joined together to create that. So these kind of designs you can achieve by using this kind of a machine. And this is a software driven thing. So what we do is, when you have, in this case, this whole table was designed by using 4.5 marble slabs. So it was optimized to that extent that number of pieces cut from that marble piece, there is very less amount of wastage. And then your whole table could be delivered within the less amount of marble so that your economics are kept in place. Then comes a CNC machine. Now CNC machines are what? They are basically three-dimensional tools. Three-dimensional tools means these machines run in X, Y, Z axis. It's a three-dimensional. Then we have 4 axes. Then the 4 dimension comes in. So that is X, Y, Z and A. Then we have a 5th axis. So when I am saying 1, 2, 3, 4, 5 and 6, then comes the robotic arm. That's a 7 axis. 6 plus 1 more moving arm, so that's 7 axis. When I am saying a 7 axis, that means it's completely like a human being. So the machine becomes a human being. You have to just you have to just compute your design, make an NC file, put it into the computer so that the machine acts like a human being and it carves or it cuts or it details or whatever design you want to make. Okay. So what all we do using CNC machine, that's a 4-axis machine that you are trying to see when we are trying to carve a concrete block. There we are trying to engrave wood. There are 2 spindles which are actually trying to cut the same design so that we can increase the speed. Then you can say we are trying to cut a molding out of a concrete block, a lightweight concrete block, and then we are trying to cut a molding out of it so that we can make an architrave of a window. At the top, what you are trying to see is cutting a marble, trying to engrave, trying to do a inlay detail inside a flooring pattern. Then what else did we do using the same CNC machine? We have cut, this is a bench that we have designed again for T1 Bangalore Airport. So this is the bench that we have designed which was cut in ply, layered, stacked and then engraved by hand. We could have also used a CNC machine to engrave it, but because of other works, we thought we will engrave it. But the best part in this is what? We have stacked it, engraved it. But the top layer that you are trying to see here, this is actually ply, this is wood. What does this look like? Sorry? Stone. Correct. So what is this stone? How did we get this stone on top of this? And again seamlessly. So this is an artificial composite marble that we usually spray. So this is a new research that we try to do. Get these things in place. We spray this out in such a way that it looks like a marble. It is a marble. It's a composition of resins, hardness and marble powders with pigments. When you mix all these things together, then you can get this kind of a design detail and make sure that your internal core, which is made up of ply, can be protected and you get a complete marble project out. So that's the research that I'm talking about that we do in our office. So these are the kind of designs that you can build. This is a small scale that I'm trying to show you right now. By using these tools, what you can do. So that's a recent photograph. That's in the Bangalore Airport, you can see. Then what else have we done? So we have designed these kind of, you can design a sculpture like this. That's a table where you can see a leg. It's been carved from a log of wood. That also you can do using a three-dimensional machine. Then these are columns. That's a 14-feet column which was again engraved by using a CNC machine. These kind of parametric patterns or center tables like this or a door where it has got design details. All these designs can be produced by using machines, by using softwares. Okay. So all this is done using CNC machines again. So you can see this is a spa that we are doing for a house. That's kadapa. Kadapa engraved to such an extent that they give you details. Okay, kadapa is a slate. If you chip it out, if you carve it out through it with hand, it may break. But using machines as a tools, you can get this kind of a design detail output. Then there are marbles that you can engrave. That's a staircase that we have done using again CNC machine. We have stacked wood one above the other, carved that out to give this kind of a design detail. Wood stacking together you can carve in such a way that it can look like a curtain. Okay, the panels that you can design. That's a bench, a parametric bench which has been carved and cut using CNC machines again. That's the process you are trying to see, and again panels. So these are different kind of design patterns that you can execute by using these machines. Okay. Then comes your metal laser cutting machine. Metal is again a very important material that we tend to use in our, in the practice of architecture. So what does this do? It cuts metal up to 12 mm thick. So it cuts NS, it cuts your brass, copper, aluminium, and SS. All the materials that are needed in the practice of architecture, it can cut, engrave, and give to you. Okay. What have we built using these machines? So that's a parking building that we are doing in Alibag. This is again a roof that we have designed for a project at Kodan at Bangalore. Okay, completely designed, having fluidic forms. Just a 4 mm thin slab sheet and a sheet over which we use 12 mm lightweight concrete blocks to create a thickness of a 20 mm thick slab. That's it. All these things are possible. Then do some interior projects like this. Do some sculptural design details for public spaces, and also do some art installations. So using a metal laser machine, if these kind of tools are there in your studio, in your office itself, just imagine what kind of outputs you can produce. So we regularly practice all this. Then this is a regular CO2 machine. I think this is the kind of a machine that you guys might be using regularly in making your own models that you can do in your college. So this is a CO2 machine. But with CO2 machine, what all you can do? We have made panels like this. That design that I had shown in metal, we did this cladding thing. There is a tabletop that we are trying to do here. Glass. We can even etch glass. This is multiple layers of glass which was etched together to make a sculpture inside a glass. Okay. So such kind of a design can also be built using a CO2 machine. So this is something which we also need to understand. When we practice interiors, there are certain kind of aesthetics that we need to look into. So these are some sculptural pieces that you can place inside your interior spaces. That's a model. It's a 120-meter long model that we have designed for an interior space in Navi Mumbai. It is an IT park building that we were doing, and we made a 120-meter long Navi Mumbai model which was got executed and which was placed. It's 120 meter by 6 meters height. So the whole town, completely Navi Mumbai is being portrayed here. So such things you can produce. Then comes your 3D printers. I think 3D printers is something which we all have been seeing for quite some time. We all know what 3D printers are, but what kind of outputs can we produce using 3D printers is necessary today. Today at Forge, what we do is we use 3D printed outcomes as a basically molds. They are the outcomes only, not the final product. So we stack them together. It's a table design that I'm trying to show you. It's a table. So that's the 3D model. The whole 3D model has been divided into 16 parts. It's printed in multiple 3D printers together, then they're joined. After joining, you can't use it as a final product. Then what we do is we insert reinforcement inside it. The way we insert reinforcement in our columns, we insert reinforcement into it so that you get the end product which is much stable and it can also take the load. So that's how a 3D printed outcome is used to get your final design outputs. What else have we done? We have been doing these different projects in Mumbai. So that's the back of the sofa that has been designed using 3D printers. That's a wash basin again. It's a chair that has been designed. It's a bench, a lampshade, chandelier, sofas. So these are interior furniture spaces that we are trying to design using 3D print technology. So 3D printing can be used in a much different way rather than using it just to make your small mock-up models. Okay, so 3D printing can change its definition now. By using multiple machines, you can build things in a much faster way. So hence today we have got a lot of 3D printers together so that we can achieve our designs in a much faster and much easier way. Okay. Then we come to concrete 3D printing. We all know that concrete 3D printing is taking up its own stage right now to build buildings. But according to me, today concrete 3D printing is something which has to be used to make not simple buildings, but those buildings which can't be built by humans. That is something which we need to understand. So concrete in India today is still at a stage where everybody is trying to experiment We are building buildings, but yes, they are simple buildings, not those parametrically designed spaces that we are trying to construct, but simple buildings, simple curves is what we have achieved today. But I think sooner or later we will try and achieve concrete as a major, concrete 3D printing will become a major aspect for all the architects, and your things will become easy. As I rightly said in the first place, transforming the information from the architect to the contractors and to the subcontractors. This is something which can change our lives. So the information is rightly sent to the right place so that you can execute your projects properly. Then comes a machine called thermoforming. Now this is a thermoforming machine where if you have got one small piece and you want to multiply the same design 1,000 times, then this is the machine that you need to use in a regular practice. So this has got a heater, that's a heater, and this is a compressor. So that's the thing where you need to put your mold, then there is a suction that happens on a material like your composite materials like wooden composite sheets that are available today. Then you have got acrylics. That is something acrylics and wooden composite materials is the only two materials where you can use in these machines so that you can create different forms. See, that's a mold, that's the end output. So when you put it onto the machine, then there is a suction that happens, that's the end output. What have we done with this? These are multiple pieces of the same design that we try to build, because this is a ceiling that we are designing for a house in Mumbai. So we wanted that kind of a design, hence we had to use same pieces, multiple pieces, make one mold, multiply it. But there are only two materials out here that you can use while using this kind of a machine, and that is your composite, wooden composite plastic, that is WPC, is the material that you can use. The other thing is your solid surfaces. And the third, yes, the third material is your acrylics. So these are all polymer-based objects, okay. These are all polymer-based materials which can change its form if you heat it up. What else you can do? Sorry. What else you can do? I mean, this is acrylic where we try to engrave using a CO2 machine and create a lampshade out of it. So such kind of designs can be built. Then comes your robotic machines. Okay. So robotics is something where I am talking about a 7-axis. So when a 7-axis machine is used, that means you are actually trying to use human labor only in terms of a machine. Instead of a human, you are trying to use robots. And that this may be the future. This is something which we need to understand today. And Pune has got the maximum number of robots in India today. So you are blessed that you are staying in and you are still residing, many of you are residing in Pune. Take the advantage, go to, spaces where robots are available, study them, learn them, because this can really help the architectural industry in a much bigger way. What have we done using robotic arms? Today we can 3D print using robotic arms. Now the 3D printing concept has changed. You have seen that earlier product that we had done was using small 3D printers. In this case, we are using a bigger robotic arm to print up to 2 meters height. Using again, this is by means of injection molding is what we are trying to do. We are not using that coil, right? We are not using the spool, the thread that we are looking at. In this case, we are using pellets. Okay. By using pellets, you can reduce the cost. That is very important again. And the best part in this case is by using a robotic arm, you are trying to print up to 12 mm thick. In the earlier case, we were printing up to only 0.4 to 0.8 mm thick. In this case, we are printing up to 12 mm thick. Because 12 mm thickness, if you are printing with 12 mm thickness, again the load factor comes into picture. These kind of products take the load. So that's a better opportunity for us. So when we are designing certain things and you want to print using a robotic arm, yes, the thickness matters and your load calculations are in place. But the drawback in this again is the speed. That's part one. Two, when you are using 3D printers, that means it is actually taking a travel path. So by using one machine, you have to travel that long. So your machine, one print will take a longer period of time. In the other case, we were having multiple machines and building things much faster because we divided each piece into multiple pieces and then stacked together. So that's the difference. But yet, I think using multiple robotic arms, I think we can derive that solution. Okay. So what are the softwares? I mean, these are the machines and these are the tools that we have seen till now. These, all the tools that I have tried to express are listed here. So these are the tools that you are trying to see. Those are power tools, CNC 3-axis, 4-axis and rotary, water jet, metal laser, non-metal laser, thermoforming, 3D printing, robotic arms, and then comes the human labor. Then what are the other tools that we tend to use when we are designing? They are these. We all know Rhino and Grasshopper is extensively used in schools today. Then we have got 3D Max, Blender, Houdini. Then comes your softwares where you try and, for the material, especially for the materials. These are all called nesting softwares. That is Cura and NestFab. Then comes your communication softwares. That means the designs that you are trying to build in these softwares, the upper softwares that I am talking about, how do you communicate these softwares, these designs to the machines? So, there are softwares like 3D Max and Rhino and Grasshopper which help you in terms of designing your details. But to execute, to give a command to a machine, what are the softwares that are needed? That is Desproto, Mastercam, ArtCam. So these are CNC CAD-CAM tools. Okay. So the CAD-CAM tools are the tools which convert your 3D models into your basic Word format details. It becomes a notepad format details. When I am saying, let us say I am trying to make a sphere in a 3D software. Now I have to convert this 3D software. I want the machine to build this sphere for me. How will it build? How will it build? The machine is actually moving in X, Y, Z, probably A, B and C, and then D. Okay. So that means there is 7 axes. All this is defined by numbers. When I am saying X, X has got 0 to 1000, Y has got 0 to 1000, similarly all other axes. So what happens is, this 3D sphere that I am trying to talk about, or for the matter of fact, any design, when this design is put into a CAD-CAM software, it converts into a notepad data where it defines X at point 1, Y at point 2, or Z at point 3, or A at point 4. So it defines the points and tells that from this is where you have to start to cut your form. It tells the machine to cut the design that you have detailed out in your machine. So you have to understand these details. For us, it took us almost 17 years. So we have been working with these machines for past 17 years out of my 25 years of practice. For past 17 years, I have been working with these machines just to understand how these machines can deliver our designs. Okay, so that my human interference becomes lesser. Machines cut and detail it out to a maximum extent, and I get my design output in a much faster way. So going into the projects, this probably will run quickly. I'm not going to talk too much about the projects. You can just see them, and then you can ask me questions. Okay, we will run all right. So this is an IT park building, sustainable building. Of course, we have used brick as the basic material. IT parks, you generally don't see brick as a base material, right? In this case, we've used brick on a larger scale. It's a 1 lakh square feet plus of a surface area where brick has been used extensively. When you are using brick, we also need to understand, first of all, this is an IT park building, which is a steel building, and we were trying to clad a brick on the surface, which is a parking bay. So a lot of vibration and a lot of frequency which goes into that facade. Okay, but brick has been used very intelligently in such a way that the adhesives, the bonding agents that we have used, have got that capability to have, it will not leave the surface, but it will move to 6 mm, up to 6 mm, and still it will stay onto its surface. Okay. The other thing is, brick is something which always attracts algae. But in this case, if you go back, so now it's almost 4.5 years that this building has been completed, but there's no algae growth on the building. The building is still like that. What is the reason behind it? The reason is we have dipped each and every brick into a narrow coating substance so that it seals all the 6 sides and it doesn't attract the water to sit on it neither the dust to sit on it so that it attracts algae. So we have to do research to that extent that you can protect your buildings for a longer period of time. This nano coating material can sustain up to 5 to 10 years maximum. After that, again you can spray it out. Your other 5 sides, only the outer surface is exposed to UV. Rest all 5 sides are inside. So you don't have to protect it again. Only the outer surface has to be protected. After 5 or 10 years, if you tend to see algae growing somewhere or the other. Otherwise, you don't need it. Okay. Due to this kind of a cross ventilation that we did, fortunately we reduced 6 degrees of a temperature inside a parking building. So you don't have to do anything, you have to just play with your materials. But the problem is, we as architects, we are not doing research on these materials and we are also not aware of these materials. This brick that I am trying to talk about is a high density brick. It's not a local brick, it is not available in Mumbai. We have shipped this material from Mysore. So these bricks are made in Mysore, the clay is different there, it's a high density brick. These bricks can also be laid on a parking bay and a 10-ton truck can go above this. But in this case, when you design this building, what we have done is, while designing the facade, we took these solid bricks, we have cut these bricks into thin pieces, thin slices, that is 12 mm thin slice. The best part in this is, those thin slices were, they were fixed to the wall in such a way that only 12 mm of the surface area is stuck to the wall which is behind. So just imagine fixing a 12 mm surface of a brick, keeping it vertical on a parking bay where there is continuous movement and still it is intact. So you have to have the right adhesives in place. This is something which you need to learn. Even in this case, what you are trying to see is, there are blocks which are arranged stacked one above the other and there is just horizontal slice of a brick. What is the bonding between this? There's just 4 mm adhesive is what has been used. If you use, because the adhesive is there, if you say that, more adhesive onto it and then you get a better bonding, no, it doesn't happen that way. Maximum is 6 mm. 4 to 6 mm is the adhesive that you need to use. If you use more, it will not bond, it will leave. Okay, even that is necessary. So technically, you as architects should know all these details when you are into execution. Okay, somebody said skyscrapers, if they fall, why will they fall? They shouldn't, right? Because we are designing them, we are building them. Then this is something, we'll run through these projects. Okay, this is an interior space of the same IT park building that we are in. So it is a long sculpture. We didn't want too many things inside the project. We thought we will design the whole project using just one single sculpture. So it's been mimicked from nature. So it's a tree detail that we try to mimic and make sure that it is fit into this plan. That's a 3-dimensional design detail. We made 3D models so that we can explain to our clients to understand how this can fit into the space. Again, this is a 120-meter long sculpture. 80 tons of steel was used to suspend it from the ceiling. So it was designed in such a way that, we had only 200 points from where we could suspend it from the ceiling, that is one. So the kind of cables that we have tried to use. So structurally it was detailed in such a way that each cable takes a load of 600 kgs per point. And again, that was distributed into the whole surface. And we derived with 200 points only, so that, and these cables are just 6 mm thin. So they look seamless. So that's how the whole process went on site. Just for you to understand, we used metal and MDF on top. And then the site has been completed and finished like this. So you can see that there are these thin cables on top. So there are these thin cables on top. Very thin cables, seamlessly detailed out, so that they don't they don't seem to be there actually when you are inside the site. Okay. Then the flooring inside this, it's an IT park building, but what is the flooring that we have used? We have used quota. So getting a quota, convincing a client, using quota in a building like IT park, where majorly today we are using Italian marbles, right? Convincing them and getting the best quota available in the market today. So we had to go to the quarries in quota and understand which is the best quota available. So we had to procure this quota where there is no variation. We had only 1% of the variation on the overall floor of the project. So So in quota we get a lot of variations, but in this case we try to achieve the best quality. We found out the best quality so that we can get the best lot. So we could get this kind of reflections after the project is done. What else have we done in this project? So this, using these machines, all these designs we could achieve only because we had machines in place. So that's the model that I'm talking about. It's a 120-meter long model. Completely Navi Mumbai has been placed on his wall. Because this project has been designed in Navi Mumbai, we thought why not, have a Navi Mumbai model on this surface, and it becomes an interactive design. Because many people who would be working in this building, they belong to Navi Mumbai. Whenever they come here, they will get connected to this model. People might think that this is the area that I used to stay earlier. Today might be I'm staying here. Maybe my school was here, my college was there. Earlier I used to work in this building. This is the sector. Those are the areas. These are the public spaces. All this. So what happens is your design is an interactive design now. So in this case, we didn't have any panel designs or any what do you say? Your Italian marbles that have been cladded onto the wall. No paneling has been done. Everything is simple, clean models, specific kind of a details that have been produced in this 20,000 square feet of an IT park space. Then the bench. This is an information desk, the entry information desk that was designed. It looks simple, tessellated. I mean, tessellated means triangulated surfaces on this. But the best part on this is the design detail that ran on the triangulated surfaces, these lines. What are you trying to see is every edge of the triangle is different, and you are transferring this line from one thing to the other. The complication rises there. How do you make sure that your design has got these kind of details? This design has got a different kind of a language. Triangles is very easy, but adding this detail of a line, transferring it from one edge to the other, the problem was there. And certain areas we couldn't find, so we had to keep it blank. So in some areas we had to keep it blank because I can't travel that line from one edge to the other. So the design stops there. You also need to understand that every surface can't be similar. So hence we couldn't achieve 100%, but yes, 90% we could achieve to travel this line. But how did this happen? This happened using parametric tools. This happened only because we had our tools in place. Okay. Then these are few sculptural pieces again as design elements which are functional pieces again. They are sculptural but yet functional. These are benches. These are different kind of benches which have been designed in this place. Then comes a lift information board. So, lift information board is what? It's just a lift, iPad that you tend to see on the lift walls. You just press a button and the lift comes in. But in this case, we thought we will design lift information boards as a concept so that it looks completely different. The design was basically conceptualized from this movie called Big Hero 6. So I keep watching movies a lot. So there is something called a microbot in that movie. So I thought why not this microbot be introduced into this space, create this kind of a space. These pipes actually carry your Cat6 cables and the power cables and give power supply and data to these iPads then. You press a button there and your lift comes at the lobby. Okay. So there is a different kind of an interaction in this space. So that is the kind of a design details that you need to understand. Then these are columns that we have designed for a bungalow in Bangalore. So design is easy. Designing sculptural details is easy. In this case, we were talking about heritage. Many times what has happened is over a period of years, we have been just copying the heritage and rebuilding it again and again and again and again. So whether they are Dodi columns or whether they are columns from Ajanta or Ellora or our temple columns, we have been building the same design details again and again. So here in this case, we thought why not we build a different kind of a series of columns, not having the same details all the time, but why do we need to copy our heritage and make a new building again and make the same mistake again? So we thought why not have different kind of design details to this bungalow that we are doing. So since we had 3D printers, we could 3D print and understand what are the designs that we can present it to our clients. So that's again a 8-feet column that we try to present it to the client just to convince him. It's very difficult when a client sees a building like White House and he knows that he wants a building like a White House for his space, and to convince him and tell him that I don't want to design a White House but I want to design the way I want to. Then you need to have tools, and in our technicians, the tools have helped us to a larger extent to convince our clients. Okay. So it took almost 6 months for me to tell my client that I want to design the column the way I am looking at architecture to be. Okay. So to convince this, I had to make almost 34, 35 feet 3D printed column to tell him that how your column actually looks like. So that's the column, 3D printed column, you can see it there. So telling your clients and making your mock-ups and showing it to them, having a mock-up ready, it becomes very easy to convince the client. Since we have these 3D printers in place, we could print the whole column, a 34 feet high column, and tell him that this is how your column looks like. And finally, we convinced him and we made sure that we go into execution. So while going into execution, what is the kind of material that we have selected here? So we thought we'll use the tools as tools, we thought we'll use CNC machines. As a base material, we thought we'll use your lightweight concrete blocks. So in this case, we used lightweight concrete blocks. They were cut using CNC machines. Multiple pieces, almost 5 lakh plus pieces were cut and shipped to Bangalore. They were stacked around your RCC column. That's the 3D printed column that you're seeing in the center, and that's how the final product went on. So those are the columns that you can see. Each piece was stacked around. Since it was digitally cut, we couldn't make any mistakes. So when everything is digitally cut, everything is placed one above the other. You can't make errors. Even your laborers can't make errors because there are reference points on every block. Every block has to be placed there only with the reference. It can't change its area. So that is something which becomes easy for us when when you're working digitally, it becomes very easy to convince your labor and get your product out. So what you can see out here is the kind of columns that we designed at the earlier stage, from the drawing at the earlier stage to the final execution, getting to the final output. It was very easy for us. So that's how it looks like. So again, a white house but with different columns. So the initial sketch that you had seen, initial three-dimensional drawing that I had shown, from there to here, there is no loss of information. That is very important when you're working with digital tools. Okay. Then there is again one more bungalow that we are doing at Kolar. Again, this is just 70 kilometers away from Bangalore. I'm just trying to show you not what I'm designing, but I'm trying to show you that how tools can help you, guide you, build your design. So you need to know the power of tools today. How this technology is trying to change the forms, change the details that you're trying to look at, and how they're making our life very easy to execute. Even complicated designs that were unbuilt earlier in India at least. Okay, abroad people are building it, but India technology, we are still behind. We are still far behind. So we thought we will build with parabolic curves. So how to get these parabolic curves in place? My intention was to have just a 20 mm thin slab. So having a 20 mm thin slab, it was very difficult for me to convince my structural consultants. End of the day, I have to become a structural consultant by myself, design it, execute it, then give the whole design to the structural consultant and say, now you can come to the site and see it is built. With respect to what I have designed, please recalculate it and give it to me. Okay, so that's how we have to practice also. So at the earliest stage, we have to make a model to understand how this design is actually going to take place. So we made a open slab below. The whole house is again designed with brick. So we call it the brick house. You can see certain kind of numbers on this. Now this is almost 70 kilometers away from Bangalore. I sitting in Mumbai, how am I going to communicate with my labor? So this is how I communicate with my labor. So there are numbers on each and every brick. That those numbers actually tell my laborers where to place the brick, at what distance, at what place. So this is how you are going to communicate. These numbers you derive it from the parametric calculations to the software. Once that is done, you can just simply pass on those details to your laborers and they know every brick is marked with these numbers. They just pick up the brick and they place it wherever it has to be placed. So that's how we could create that facade. The project is still going on. So we have created this facade. That's how the details were. It is this, if you see, they're just triangles. They're just inserted triangles, but you can see they are in layers. So every brick, when they are put in layers, you get this kind of a parametric design outcome. Okay, and they're perfectly placed, no errors. So that waffle that you're trying to see, that's there. The whole bricks will be placed properly. Internally, we have decked up with wood, a pine, 6 mm thick pine wood, so that we can get some insulation. The top, that's the interior. This is what is going on. So that's a waffle slab that we tried to create earlier, just to understand that the form is built properly. So this is the structural member, it's called the centering. Okay, that staging that we tried to do at the earlier stage, and on which this 4 mm thin sheet was cut using tessellated formations from the parametric tools that we had. Each piece, a triangulated piece, was cut, taken to the side, it was welded properly by placing it onto the waffle. Okay, so that we can achieve so we can achieve that kind of, so we can achieve that kind of a thin design sheet. Okay, so just imagine a 4 mm thin sheet. It's a complete slab on which people are also working. You don't need more than 4 mm also. Just imagine that. So such a slab can be derived just using a 4 mm thin sheet using parametric tools. Okay. But we have to make it 20 mm wide. I needed this insulation. So I have a concrete 12 mm thick lightweight concrete blocks which I pasted onto the MS sheet so that I can protect it from weather, one, and also have an insulation on top of it by doing a little waterproofing on top of it. So that's how the whole slab went on. With again a underdeck, which is again a 4 mm, 6 mm, your pine wood. So that again protects me, it's a double safety layer to protect it from heat. Okay. So that's how the whole project went on. So it's still going on. So you can look at people working on top of it. You can literally walk on it today. Okay, just a 20 mm thin slab. You don't need structural engineers. Of course, we need structural engineers, but because these kind of designs are something which we are trying to, by communicating with software and machines, we are trying to build them. Our structural engineers are still not ready to help us out. But today, after a practice of 17 years, we have got few of them on our board who are trying to help us out in terms of getting these designs executed now. Okay. So at the earlier stage, we had a lot of problems. Then this is a furniture piece that I'm going to show you. It's a 25 feet long information desk. Again, sci-fi design, derived from the Avatar movie, part 2. So we used WPC as the base material. So it was not one bench, these were 2 benches stacked together. If you see this hole, what is that hole meant for? That's where my reinforcement goes inside, so that I can give strength to my object. So then what we do is we spray composite marble now. So that's how the things went on. The table from the design to execution, the spraying is happening. There are lights also which are incorporated into the detailing. So these are 2 different pieces, 2 different mirror images, not the same kind of a design but mirror images. So again there is no loss of information. Same design was built with the keeping in mind that it is an opposite, it's a mirror detail. So here we try to design and build it so that it is using composite material as the top coat so that I can protect the internal layer. WPC is a lightweight composite material which can be easily cut and engraved. Hence we use that. It's a very lightweight material and a 25 feet long table would be detailed out in such a way. So what I was saying is the loss of information. I've been always talking about loss of information. So you have to understand that these softwares keep on helping us out in terms of deriving to the end output. That is something which you need to follow. Then in the same space, we've also designed few art installations in the same building. So this is a Bandra VPC. So this is a wall installation, that's a 3D. This is very close to your backwaters. This is Bandra. So we thought we will derive whatever design that we're trying to build inside this place, we will try and mimic from water. So that was the basic concept. So this is again the roots of mangroves, that's what we try to mimic. So So that's the basic model, divided into multiple pieces. That's the final output. So what material we have used out here is we have used MDF as the base material. We could have 3D printed the whole project and could have done this project, but we thought we'd take a little more challenge, try and use MDF so that we can understand whether MDF will support us to get this project done or not. So we used MDF as the base material, tried to again spray it with composite marble, fixed them together. These holes are for anchoring onto the wall, and the end product. So there is a mirror behind which actually reflects inside and it looks like as in one piece. Then there is a package screening, there is a separator inside the same premise. So this is again derived from the corals. Okay. So it has been divided into multiple pieces. Every piece, I mean, in this case again we have used lightweight concrete blocks to get this project done. So multiple pieces were engraved using CNC tools. Each piece again has got 4 pieces inside this. They were joined together. One number missing, you're gone. Okay, you can't do that. So every number has to be placed properly. Every piece has to be numbered in such a way, and they have to be placed properly so that your people working there can understand and place them properly. So that's how the whole thing went on. So the final finishing, we have got H40 at the top coat. H40 is again an adhesive that we are looking at today to give a better bonding to your material, your base material. So that's the output. We have also integrated light inside the project. So light was also an element to enhance the space. So that's how precise you can get your design outputs here. You can see how precise it is from your design information that was built in a 3D software, going up to questioning and getting an output from human labor. Now this is one of the most complicated design. The design was not complicated, but the most complicated object that we have ever built till date. Because in this case, the design, you can see that it has got the organic form, but the best part is there are these lines on this form. Now we wanted to transfer these lines on the object as it is. We didn't want those lines to go off. But how are we going to make these lines with? We selected a material called metal, that is brass. A 4 mm by 4 mm thin solid brass. Bending that brass into a doubly curved surface was the basic challenge. That took us almost 6 months to complete this 16 feet long table. It's not easy at all. In our office, we keep on doing research all the time, trying to understand different materials, their behavior to us, how they can help us out in getting our products done. So in this case, what we've done is there is this marble on top and this brass inside, which is done as an inlay. So this is the basic graphic model that we usually get out from our your Rhino software, right? So taking this model as the base output, we thought why not have these lines and this as a solid stone. So those lines, that brass is something which was very tricky at the end of the day. So what we have done is using again your waterjet machine, we have cut marble, multiple pieces of marble, which was stuck onto the wood. But laying this metal was the most difficult part, which took us almost 6 months to complete the project. Placing that, technically it was very hard, bending it without any dent onto the metal. Once the moment you bend it, there will be a dent on the metal. And the dent is something which you can't remove it again. So you can't have those dents. So end of the day, we could achieve this design as it is that we try to create in our 3D model. Okay. So that's the output that you're trying to see. So it's a 16 feet long table having the same details, every line that was created by the model using parametric tools, they were transferred onto the actual product. So that becomes very tedious. So you need to understand materials a lot. So end of the day, we achieved it. Everyone in the factory, we came together to celebrate. So that before sending it across, we achieved our biggest goal. We thought how these materials would be dealt with. So different staircases, I will just quickly run through, you can see them. So there is a staircase designed by Andrew Spalfinger. He's an associate to Mad Architects at New York. He was here at Mumbai at our premise. So we have an event at Folds, which is called Unfolds, where we try and tell people that what we all do at our factory. We also invite different architects from all over the world. So we have 3 different architects this year. They came here, they took workshops, they taught students what AI is all about, what digital architecture is all about, what fabrication is all about, how these tools can help us out in terms of executing our projects. Okay. So it's a 6 days event that we usually do every year, where people come from all over India, sit together, understand these designs, understand these details, how to fabricate them, how to make sure that these designs become stable also, because they're not just designs which are done in software and just put on, just posted onto your Instagram pages, but they're also executed. That is something which we need to understand, not large scale but small scale, still stable, you can still use them. That's the most important thing. That's and use with those here in Mumbai. Then the building that we're doing, it's a facade that we're trying to design. So designing a facade is also not an easy task. Getting your environmental calculations in place, multiple details. In this case, we have used control net. Using stable diffusion, we try to produce certain kind of a design parameter, certain kind of a design pattern to our building. The plan was designed by some other architect. We are just doing the facade. So we try to calculate it through using two software, that is control net and your stable diffusion, and get a design output. So that's the basic platform of stable diffusion, where we are trying to achieve different kind of patterns by using just images and having some kind of prompts. Just putting some prompts, we try to achieve our end goal. What kind of a design process that we can achieve. This is where the whole magic is happening. These are all tools where we try to put a prompt, and this is the image that we are trying to put. Okay, that's a sketch. Then that's the end outcome. So from the end outcome, all this is happening within just 10 minutes. Okay, just imagine you are trying to get your design within 10 minutes. That's the best part. That's the beauty of software. Okay. So after getting the output, we made a 3D model. So this is a facade that we have designed for this 22-story building at Andheri, which is coming up. So that's how it looks like. So these are the areas where lesser sun is impacting. So hence we have got bigger openings. These are the areas where the sun is impacting on a larger scale. So we have got lesser openings here. So it's all calculated. There is nothing that you can't do today. Then this is a bungalow that we're doing again in Thane, Mumbai-Thane highway. So it's a 13-story structure, parametrically designed, using different kind of materials, multiple things, multiple details, cross-sectional details, just to understand how the wind pattern can be detailed out inside the building, how a facade can be designed again, using landscapes inside the building at different levels. The building is actually reversely designed. In this case, our entertainment spaces are on the top. We have a kitchen and the living room at the upper level, and the bedrooms are there at the lower levels. That's how the whole building was designed. The best part in this is we have our cars going to each and every space inside the building. Every floor, the car goes up to your bedroom. That's how it has been designed. Because the client is very fascinated with cars. He's got multiple cars in this place. So he wants his cars to be used as, art pieces inside his house. So we thought, why not design it in such a way that, he takes his car to his bedroom or a living room or to a kitchen also. Okay. Then this is a project that we're going to start now in Jamnagar, which is an office space. This is the first project where we have designed completely using AI tools. Completely using AI tools. Nothing here has been designed without the help of AI. Okay. So just prompts, detailing it out, writing proper prompts to create the outcomes. So again, sustainability is the major factor here that we try to look up to. That's a cross section. So you can see it's a 2 lakh square feet of office space. It's a very high office space in Jamnagar. We know the climatic conditions there. So in this case, what we have done is there are a lot of open spaces inside the building where the wind flows. So there is glass which has been used, but all are open glasses. They are not fixed glass. So less of air conditioning and having more brickwork inside the detail was taken care of to get this kind of a design process. Right now it is at the process stage. We are still working. We are trying to find out, optimize it to such an extent that we use less amount of material and not use too much amount of air conditioning inside this place, because Jamnagar is a place where there is a lot of heat. So using less amount of air conditioning is what our major goal is here. So trying to still find out solutions, but using technology again. So that's how the building looks like. Soon we are going to start this as well. So these are few residential projects which are ongoing. Forms is something which we work. Mandir, staircase, beds, bed bags, TV units, wash basins. Every piece is designed, detailed, keeping in mind that they can be built again. A bed design. This is a recently completed project, just completed. Last Sunday we inaugurated this space. So here in this case the client is an architect for me. So this space belongs to an architect. A young architect just passed out 3 years back. So he wanted me to design a space. So it's his bedroom. There's a living space. We just finished it. So for you to understand that these spaces can be, I mean the spaces that we're trying to design are also big. They are not just on, they're not just as images. Chairs, your art installations, your furniture pieces, your sofas, your TV unit, everything is ergonomically designed and placed there. It's not that you're fascinated with designing and building it. It's not that at all. Everything is ergonomically designed with keeping in mind the proportions. Even the sculpture is being made by us. So that's how they look like. Even the lampshades. So we have Rani sitting here, he was part of it at the initial stage. One of your colleagues sitting here, my Rani. So luxury spaces, but still changing the concept of the design detail, getting some organic forms, biomimicking forms, getting them into your residences now, making sure that people try and use these kind of forms today is what we are looking at. So we still have not photographed the whole project. So again, using AI as the basic tool, having our design language, how we are trying to generate our own designs. Not letting AI give its own solutions, but using our design language and AI giving solutions to us with respect to what kind of designs we look at. Okay. So we start with sketches. That is very important for us. Everything that we do, we start with sketches. Without sketching, we don't do our projects. That is one thing which we religiously follow at our office. So every design goes to a sketch, then we put that into our software and understand it better. So that sketch, putting that sketch into our AI software and getting our animation done, and this whole thing happens within minutes. So the best part is the initial presentation is something which we all look for, right? So we don't have to put too much amount of time into making the initial presentation and getting the project done. So the other street furnitures, this is the project that we are doing at Culture. These are the initial presentations that we are trying to bring up. Our own designs, new solutions. That's the building that we have designed. Putting this into the AI tool, we are trying to get new solutions using. Here we use brick. Here we are using laterite as a base material and getting the outputs. Again, this column was designed by us. We are trying to get different outputs, keeping in mind the base as our design. Multiple details, again generated from the same column. Designing from our own details, we are trying to create furniture pieces, something like these. A lift, which you can also detail it out as a pod. Earlier we have seen a lift information board. That same board becoming a lift capsule is what we try to create. So this is what we have proposed for the Jamnagar project. If you want to design your townships, just like prompts, you can get your basic design details in place at the earlier stage. Not the complete design, but at the earlier stage, so that life becomes easy. Okay, as architects, we slog a lot, but we don't achieve too much. So these tools are helping us out today to some extent, where we can seriously present our initial concepts in a much bigger way. So we are also talking about skyscrapers, what might happen tomorrow. So probably this is what might happen to see tomorrow. Maybe these are the things that we might be using as our transportation. Maybe not metros any further. Maybe not roads. Maybe this is what we are going to try and use tomorrow. Then are we seriously ready for the future? If so, then what? I mean, these are the questions that we keep asking at our Pune Graphic. Thanks. Any questions?
Hello, so thank you for this amazing lecture. So my question is, you were talking about taking inspiration from movie like 5006, Avatar, and stuff. So I want to know how, what's the process behind it? If you could explain it in the simplest way possible, step by step.
So the process is these first 5 years that we're trying to learn in the college. Okay. The whole education actually comes from here. The whole inspiration actually comes from here. Okay. First we need to be very strong in those first 2 years and then the next 3 years. If you are dedicated to the profession, to the subject especially, then I think this whole thing is very easy. Inspiration can be borrowed from anywhere. Whether it could be movies, whether it is through talks, whether if we are seeing our heritage projects, inspiration can be derived from anywhere. Right? The end outputs matter. Today we are all talking about mimicking nature. So for me, for past 5-6 years, we are thinking about how to mimic nature first, convert that into drawings. First priority was convert them into drawings. After converting them into drawings, getting them executed. So if I have to transfer that drawing into an execution module, what is it that I have to work with? That is materials. So what are the materials that are there with us today which can guide, help us out, execute these projects? There are multiple materials. What is the process? Then in this process, I need labor. I need labor. So if, to avoid labor, what am I supposed to do? I'm supposed to have tools. So that's the basic process. So from design, taking the inspiration from movies, anywhere, the matter of fact. I traveled a lot at the initial stages. Okay, traveled a lot. The first 10 years, I traveled extensively worldwide, learned things, how they're managing, how they're executing. In India, our problem is with the labor. Abroad, every labor is educated and qualified. They understand technology. In our case, our labor is unskilled. So that's the biggest loss today. So to bridge that gap, I have to get technology into my practice. That helped me sustain so long. Now, the thing is not only about sustainability, the thing is also about understanding the different materials. One, all these materials were there, but they were used in a very systematic way, very simple way, not in complicated way at all, till now. We try to change the definition and say that these tools, these materials can actually be carved and executed in a different form, in a different way by using tools. So we try to connect tools and materials and the design language that we are looking at together so that we can go ahead. For me, I don't want to replicate the designs. For me as a designer, as an architect, I feel that we need to create history rather than copy history and make the same history again. History is already there. So we need to learn that what mistakes they have made, try and not make the same mistakes. Maybe we change the design, create a new history for the new generation that is coming out, so that after 50 years or 100 years they find that this design is something which they were looking for, or probably after 50 years there is a new design that we should have find. I'm going to teach. Right. So inspiration can be derived from anywhere. Most important thing is to how to run this system, the design process. So designing tools which are software, using machine technology, then using labor. Combining this, your outputs are there. Exactly. So we use lateral also. I've not considered all my projects. So we have 3 hour journey. So we have very limited time. See, here, I mean, since I've got machines, I've got CNC machines. Using CNC machines, I can carve out. I've got robotic arm also. So we can carve out stone. That's what I said at the initial stage. Right. So getting this in place is very easy for us. It's not at all difficult. You have to just play with gravity. Today we are doing a project at Bhavnagar. We're building a pyramid for Oshos. Okay. It's a pyramid. Constructing a pyramid is very easy. But constructing a pyramid without using steel, that's the difficult part. Why? We are working with surfaces like this, at inclined areas. Okay. Now the client wants the pyramid to be built exactly like Pyramid of Giza. Okay. We all wanted to copy West. That's the logic. When the project came to us, we said, why not do a research? After doing a lot of research, what we found is the principles of on which Pyramid of Giza was built and the principles of Sri Lanka were actually same. They're actually same. Every angle, every detail is same. So we were wondering why should we copy Pyramid of Giza rather than why not we build these things using principles of Sri Lanka. So we are building this project using again concrete. Okay, this pyramid using concrete. So concrete is again it's a high density material. How do you work with an inclined surface, right? So we are playing with the gravity of the object at different layers. We are having a high density block below. Slowly, and in the way it goes up, the layers change, the density changes, it becomes lighter. So it is being designed on the principles of simple diety. You know diety, right? Going on that we see. So the principle is the base has to be stronger, lighter people have to be above, and the top is the keystone. That's how we have designed. And principally we all agreed, and today the structure is also in place to get this building executed. And there is no steel that is getting used. It's just pure concrete that we are trying to build this with. Everything is possible. So similarly in this case, what we are trying to play with is the gravity. Because it's going like this. Stone, you have to bond them properly. Right. So there has to be a reinforcement inside this. In this case, the client is not saying that he doesn't want reinforcement. In that case, he wanted the client had a specific reason that he didn't want steel. Because it is a meditation center. We didn't want any, the magnetic forces inside that space. So hence he said he doesn't want steel at all. So it was a design challenge. So we just started the project. So these are new things that we need to work with. Okay. So in this case, it is laterite. Since the tools are there, you can execute. Best thing is that. Okay. So there is something called Superflex. Superflex is a chemical which is a PU based chemical. Okay. So it is a PU based adhesive, basically. So what happens is regularly we use cement based adhesives. Okay. Cement based adhesives after a certain period of time, they are brittle. I mean they are too stiff. Okay, it's concrete, right? It's too stiff. If there is a vibration that is happening, once there is a crack, it will lose its bonding. Okay. Superflex has got a PU based adhesive. Okay. So it is more like an elastic. You stretch it. Okay. What happens is when there is a seismic calculation that is happening within the building, or if there are vehicles which are moving, so there are vibrations which are happening in the building. The material that is actually trying to bond is brick to the internal wall, right? Again, that is concrete. So the adhesive that we can use is superflex, which is PU based. So which has got the elasticity to stretch up to 10 mm. We are only looking at the gap between the bricks is just 6 mm. So what we are looking at is the brick may move up to 6 mm top, bottom or front. So it is not going to leave even if there are vibrations. So the adhesive that we have used on the Superflex, the brand is Caracol. There are multiple companies. Caracol is a German brand. There are multiple chemicals today in India today itself. I think there's something called Walnut. It's a brand. So they have got all these adhesives. Then there is also called a brick adhesive. In this case, brick adhesive, but we are using Superflex. But brick adhesive, when you join brick to brick, normal bricks, you are trying to stab one into the other. There you have to use H40 or a Bioflex. So that is again a chemical. Okay, but it is water based. It's not PU based. There you don't need to bother with cracks. because it's setting one above the other. In this case, I'm trying to lay one above the other but on a surface. So there is always a tendency to fall because of your vibration. But in this case, when I'm going to make a wall, then you put plaster which is coming. Right? So there is a multiple protection here. So there are different materials for different areas. So if you want to bond brick to metal, what do you do? What do you do? Right? So there is this material called superflex. So superflex is a material which will bond two different materials. And wherever there is a friction and wherever there is a positioning where your material is going to move, right? Then this is something which you need to use. Every PU based adhesive is something which you need to look into. When you are working with different materials to bond together. So if you have a metal here and you want to clad stone here, so you are trying to clad stone against the gravity. Right? So it's going to push. But if the adhesive is PU based, so what is happening is it is actually fixing to the metal, it is also fixing to your stone. The stone has got a specific density, a specific weight. Every square feet of a stone, if it is 20 mm, it weighs 5 kg. If it is going above 5 kg, you have to use a different adhesive. Up to 5 to 10 kg, you can use superflex because what happens is it will stretch before it dries up. It stretches up to 2 to 3 mm and then it stays like that. And if there is a vibration, it will move, but it will never leave. Okay. So the adhesive takes care of everything. All these things are necessary to learn in the institute.
Thank you, sir, for such an impactful session. It was truly motivating, and we also could work on our ideas now so that we have a direction. So now let's break for lunch, and we'll meet at the auditorium again at 2:30. I request all the experts and faculty members to join for the lunch at the VIP lounge. And students are requested to be seated at the